Ma'am, good morning, ma'am. Good morning, ma'am. Good morning, ma'am.
Good morning, sir.
Good morning, Jason, sir. Sir, good morning, sir. Good morning, sir.
Good morning, good morning.
Good morning.
Sir, unmute பண்ணாரு.
Oh, sorry, sir. Streaming வருதுங்க sir. YouTube.
ஓகேங்க சார், ஓகேங்க சார். சூப்பர். சூப்பர் சார், தெரியுது.
Sir, good morning, sir.
Sir, good morning. YouTube live is working, sir.
ஓகே. இல்ல நேத்தே ஒர்க் ஆனிச்சு சார். நேத்தே யூடியூப் ஒர்க் ஆச்சு.
அதான் இன்னைக்கு புது லிங்க் சார். ஒரு நாளைக்கு ஒரு லிங்க் கிரியேட் பண்ணுவோம் சார்.
ஆமா.
சார் நம்ம யூடியூப்ல கிளாஸ் எடுக்கலாம் போல இருக்கு. டெய்லி.
Sundar sir, good morning.
Good morning, sir. Good morning.
முகத்தை காட்டுங்க சார். ஜிஎம் சார்.
Good morning, sir.
சார் வாங்க. முகத்தை காட்டுங்க. என்ன நீங்க?
எங்க வந்தாரு போயிட்டாரு.
உங்களுக்கு நல்லா இருக்கு சார் கேமரா. சுந்தர் சார் கேமரா நல்லா இருக்கு. பின்னாடி பயங்கரமா அப்படியே ரெட் தூக்குது. சைடுலாம் கலர் கிரீன் ப்ளூன்னு
பேக்ரவுண்ட் சூப்பரா பண்ணிருக்கீங்க. சுந்தர் சார் பேக்ரவுண்ட் பயங்கரமா பண்ணி வச்சிருக்கீங்க. டெக்கரேஷன் நல்லா பண்ணிருக்கீங்க.
வீட்ல இருக்கதான் சார். இதுக்குன்னு தனி என்ன டெக்கரேஷன்?
சரி, ரைட் சார்.
எனக்கு லைட்டிங் வந்து முகத்துல இருக்கிறதுனால பிரைட்டா இருக்கு. அவ்வளவுதான்.
ஓகே.
வெளியில இருந்து சன்லைட் விழுந்தா இது எதிர் இது நான் ஸ்கிரீன் போட்டேன்.
ஓகே சார்.
நல்லா இருக்கு சார். கலர்ஃபுல்லா இருக்கு. கூகுள் கலர் மாதிரி இல்ல, நிஜமா கூகுள் கலர் மாதிரி இருக்கு அப்படியே பாக்குறதுக்கு.
ஏதோ
சூப்பரா இருக்கு சார். இவருக்கு அனில் பிள்ளைக்கு போன் பண்ணிட்டு வந்துடுறேன் சார். அனில் பிள்ளை சார் இருக்குங்க சார்.
ஓகேங்க சார்.
வந்துட்டாரான்னு தெரியல. இதை பாக்குறேன் சார்.
ஹலோ. எப்ப நம்ம எல்லாம் நேர்ல பாக்குறோன்னு தெரியல.
Hello, good morning, sir.
Sir, good morning, sir.
Yeah, I am online now. No problem.
Sir, Anil Play, sir.
Yeah.
Sir, good morning, sir. Very good morning, sir.
Good morning. I heard that you were about to call me, so I thought that better.
Oh, yes, sir. That's why I'm trying to call you. Thank you, sir. Thank you, sir. I'll make it.
I'm ready. I'm ready with everything. Just let me know when to start and take your time. No problem.
Fine, sir. Sir, you are login with
AVG Chem.
Sir?
AVG Chem.
VG Chem. Yeah, yes, sir. So I have to make you as a co-host, sir. That's why.
Yeah.
Oh, good morning, sir. Good morning, sir.
Madam, good morning, madam. 1 minute, madam. The resource person sir வந்திருக்கார் மேடம். அவர் co-host போட்டு introduce பண்ணிடுறேங்க மேடம். VG Chem. AVG Chem.
Yeah.
Yes, sir. I have given co-host to you, sir.
Yeah. Got
Sir,
it.
now it is ready, sir.
Sure, no problem. Just let me know when to start. I'm there. I'm online now. No problem.
Yes, sir. Definitely, sir. We can start exactly at 10:15, sir.
It's up to you. It's up to you. I'm ready for anything. So,
Thank you, sir.
Because
Thank you,
I
sir.
know it's not that easy. Arranging the things online,
Yes,
getting
sir.
things together. It's okay. That's fine.
Yes, sir. Our HOD is there, sir. Our HOD, Dr. Indira Gandhi Madam is there, sir. She want to say a few words about it, sir. Please,
No
sir.
problem. No problem.
This is
morning,
our
ma'am.
madam, HOD ma'am, sir.
Good morning, madam.
Good morning, sir. Good morning, sir.
Good morning. Good morning.
This is our HOD ma'am, sir.
Actually, I saw the email in the invitation Indira Gandhi. So I was afraid in the beginning, because because our the Prime Minister of India. So I was just worried about. Anyway, good name.
Sir, this is our senior professor, sir. Dr. Jaishankar. Dr. Jaishankar, sir.
Good morning, sir.
Good morning. Good morning.
Happy to invite for the webinar, sir.
Thank you very much. Thank you.
This is our my best friend and colleague, sir, Dr. Sundaram.
Yeah.
Sir, good morning, sir.
Good morning. Good morning. He's looking very smart, with the colorful background.
Yes, sir.
Hello.
Sir, good morning, sir. Personal, sir. Good morning, sir.
Hello.
Hello.
Sir.
Hello.
Yes,
Hello,
sir. Good
sir.
morning. Romba smart, Sundaram sir.
Sundaram, sir.
Sir.
ரொம்ப ஸ்மார்ட்டா இருக்கீங்க சார் பாருங்க சார்.
சார் அதெல்லாம் ஒண்ணும் இல்லைங்க சார்.
பாருங்க நான் சொல்ல சார் சொல்றாரு அங்க இருந்து. வாங்க மேடம். குட் மார்னிங் மேடம்.
Good morning.
குட் மார்னிங் மேடம். குட் மார்னிங் மேடம். அச்சோடி மேடம் கூட லைன்ல இருக்காங்க மேடம்.
சார் குட் மார்னிங் சார்.
சாஸ்திரி சார் குட் மார்னிங். எங்க இருக்கீங்க?
நல்லா இருக்கு சார். நல்லா இருக்கு சார்.
ஓகே சார். சார் கேமரா ஆன் பண்ணுங்க சார். தெரியலங்க சார்.
சார்
கேமரா ஆன் பண்ணுங்க சார். தெரியலங்க சார். கேமரா உங்க வீடியோ.
சரிங்க சார் பாக்குறேன் சார்.
சார் பிஜி ஸ்டூடெண்ட்ஸ் எல்லாருமே வந்திருக்காங்க மேடம். சார் சாஸ்திரி சார் குட் மார்னிங் சார்.
சார் குட் மார்னிங் சார். குட்
குட் மார்னிங்.
மார்னிங்
சார் குட் மார்னிங் சார்.
குட் மார்னிங் சார். குட் மார்னிங் சார். ஓகே சார்.
Sir, Parshuraman Jaishankar sir, good morning sir. Parshuraman sir. Sir, Parshuraman sir. Madam, WS madam. Madam, WS madam. Okay, madam. Thank you. Sir, Anil sir, good morning. Anil sir.
Yes, yes, good morning.
Sir, this is our madam, my colleague, Dr. W. Shanti. He is going to come here in today's program, sir.
Oh, no problem, no problem.
Good morning, sir.
Good morning.
Sir, Parshuraman sir, good morning, sir.
Good morning, sir. Good morning, sir.
Sir, in your photo, you are too young, sir.
Yeah. Photo is, now things have changed.
Yes, sir.
I put on a lot of weight,
Yeah.
so obviously the things will change.
One Tamil movie is there, sir. Gauravam. Gauravam Swathi like you are looking like Gauravam Swathi sir.
Yes, sir.
Oh, thank you, thank you.
Really super, sir.
Madam, good morning.
Good morning, sir.
Good morning.
Madam, good morning, madam.
Good morning, sir.
Madam W, madam HOD, madam. Madam HOD, madam.
Yes, sir.
மேடம் ஸ்டார்ட் பண்ணிடலாமாங்க மேடம்?
Yes, sir. You can start, sir.
நீங்க பேசுறீங்களா மேடம் இல்ல டைரக்டா டபிள்யூஎஸ் மேடம் ஸ்டார்ட் பண்ணிடலாமாங்க மேடம்?
You can continue, sir.
மேடம் மேடம்
I need not say anything, sir. You can directly-
ஓகே மேடம். அப்ப டபிள்யூஎஸ் மேடத்தை ஸ்டார்ட் பண்ண சொல்லிட்டீங்களாங்க மேடம்?
Yes, sir.
மேடம் மேடம் டபிள்யூஎஸ் மேடம் நீங்க டேக் ஓவர் பண்ணுங்க மேடம். Yes.
Yes, sir.
Good morning and welcome to the second day of the webinar, Advances in Pure and Applied Chemistry, hosted by the Department of Chemistry, Presidency College. Let's start this technical session now. The first presentation of the day is on Sustainable Technology from Green Chemistry Perspectives by Professor Dr. Anil Vittal Gule, Professor of Chemistry, Department of Chemistry, Shivaji University, Kolhapur. He is also the Director, International Affairs Cells and Director, Intellectual Property Rights in Shivaji University. Dr. Gule received his doctoral degree in chemistry from National Tsinghua University, Taiwan. Not only chemistry, he has also received BSc degree in botany, law degrees LLB and LLM with core interest in intellectual property rights. He has good international collaboration and had worked at Hanyang University, Korea, Naveda Nanotechnology Center, Las Vegas, National Tsinghua University, Taiwan. He has 19 years of multidisciplinary research experiences and had worked on several interdisciplinary projects. His research interests are mainly focused on developing novel materials and devices using greener approaches. He has published more than 130 research papers with H-index 28, ITIN index 72, and 2585 citations. It's our pleasure to have such a great personality with us today, and over to Dr. Gule for the presentation.
Thank you very much for your kind introduction. So I better start with the presentation today. Can you see the screen? I mean,
Yes, sir. Yes, sir. Yes, sir.
Okay, so good morning, everybody, all the participants, the organizers, Professor Muthukumaran and all his colleague staff. I cannot take the names of all the guys, but then I thank you all for inviting me and giving me the opportunity to share some of my work over here.
Good morning, sir.
Today's topic would be sustainable technology from green chemistry perspective. So we'll just begin with the things. So this is, for your information, this is our university, it's the main building, and this is the statue of Shivaji Maharaj. With, like in his name, the university has been there, and it's one of the best universities in Maharashtra. So before I start with my presentation, I usually share this slide, and I like this slide from the point that, this is an inspirational slide. If you look at the slide, if you look at carefully, what you see is a rooftop with a plastic bottle. Plastic bottle is typically polypropylene bottle, and I'll tell you that this work was done by a Brazilian mechanic. So for research or for innovation, you need not have formal education or listening. Anybody can do research and anybody can achieve anything in the life. It's that easy. If you look at this picture, you'll find a polypropylene bottle, and it is led halfway down from the roof. Now, what is the story behind this? Now, the title here says that one man's trash is another man's treasure. So, it's about recycling. So what this Brazilian mechanic does, he has done that. If you look at this bottle, the cost of this bottle after consumption of the soft drink would be less than 50 paise, or we'll assume that it is 1 rupee. Okay. So what the Brazilian mechanic did is that after consuming the soft drink, he cleans that bottle with water, and he filled the bottle halfway down. And then he adds some bleaching powder with the purpose of avoiding the growth of microbes. And then he made a hole into the rooftop and let the bottle halfway down. So what happens is that when the sunlight falls on this bottle, the light scatters through the water and it illuminates the dark room inside. And just imagine the light, how much is the illumination? It is equivalent to a 50 watt bulb. Just imagine the scenario. If you are, glowing a 50 watt bulb for a night, it will consume at least one unit. So 1 unit somewhere around 10 rupees. So, or you can calculate that, for a month, it's about 300. So this is very appreciating, because there are many places in India itself where there's no, there's no electricity. And there are many huts wherein even in the daytime, like, there's dark. So such kind of simple and cost-effective technology, a cost-effective idea could be used in many places. Now you'll say that this is possible only in the daytime. What about in the night? Now it is very much possible that, because if there are houses in most of the villages or in most of the urban areas, most of the houses are in a row. If you have these kind of thing, and if you put one floodlight any place, and then if you use a mirror, you can illuminate all the bottles up there. And no, we cannot expect very bright light in almost all the room, but this is very much possible in places where there is scarcity of light or there's no electricity. Absolutely. So in this case, at least some light. So that would be a good. I mean, so from this slide, what I would like to tell you is that, creating ideas, like it's piece of cake for everybody. I mean, anybody can come up with an idea. Okay, so you should take inspiration from this. And there are another idea is like, you could also use optic fibers for illuminating each bottle by keeping the main source in one point. So that's how we can provide light in the where like people are deprived of electricity, at least some light in the night at least. So that is the idea. So this is something which is important. So what I would like to tell is from this slide is that everybody can think innovatively and come up with innovative ideas. And already like our Prime Minister has already announced Atmanirbhar Bharat. So you have to come up with innovative ideas hereafter. So to make India the best in the world. So like this is a common slide which everybody shares, and it's a common slide. As I tell you, my topic is all about green and nanotechnology. So in the initial slide, if you look at this slide carefully, when you talk about human being, we talk about the size of 1 meter. When you talk about the pinhead size, it is the dimension of, like, say, 1 millimeter. When you talk about RBCs, WBCs, microelectronics, we talk in the range of micrometer. DNA and RNA in the scale of nanometer. Atoms in the range of Armstrong. So whenever we talk about nanotechnology, we talk in the range of, like, say, 1 nanometer. Now, the thing is that all the carbon nanotubes and all these things, they come into this region. Why people are interested in nanotechnology? That's because of the high surface to volume ratio. Like, we'll see eventually what is that. Now, the thing is, the first question comes to mind is why people are interested in, like, nanotechnology. The very reason is high surface to volume ratio, and like it has tremendous application because talking about its application in catalysis for chemical reaction as adsorbents for molecules or pollutants, viruses, and even in present scenario, a lot of applications are there for nanomaterial as long as you're going to apply them in the technology from technology perspective. Now, the thing is that, like, if you look at the right side image here, if you take one shell of this thing, the like assembly of few atoms, like if there are 13 atoms, like to make one shell, the percentage of atoms on the surface is like 92%. When there are two shells, including for 55 atoms, the percentage is 76. So as you grow on making the size bigger and bigger, the percentage of atom onto the surface is reducing. What it means is that the active sites are reducing because there are more number of atoms, but some of them are encapsulated inside and those not available for reaction. So ultimately, like with the increase in size, the number of atoms or the exposed sites are reducing, obviously. So the bulk material is more, but then the number of active sites for reaction is less. So ultimately, bringing down, even if you're using it for catalysis and all these things, if you're bringing it down to the nanoscale, obviously it's going to be useful from the point that the surface area and the active sites will be increasing. So this is very essential. Another thing is that, like, tunable size and quantum. If you look at the thing, why nanotechnology is interesting, because this is the image below, which is a colorful image here. It's a CDSE ZNS quantum dot core shell structure, right? If you change the size from 6 to 2 nanometer, there's a significant change in optical properties, right? So that is something which is interesting, the change in the size. One more thing I would like to talk to you is that you might have heard about MSDS, right? When you talk about chemistry, MSDS is very common. MSDS is material safety data sheet. So whatever properties associated with the material, let's say physical, chemical, or whatsoever properties associated with the material, those are recorded in MSDS for the safety and security of those who are going to use those chemicals. But now whatever properties they've been like obtained or characterized for a particular compound or molecule or like chemical, that is based on the bulk material. There is no report of the chemical physical properties of all these materials, because if you see the scenario, when the nanomaterial changes from bulk to various sizes, the properties are going to change eventually, and we don't have MSDS for all the different size of the material, or even for one material. So there's a lot of scope for people to work on in this direction. Like, if a material changes from say 20 to 10 and all this thing, the properties are going to change. So whatever MSDS right now we have is for like the bulk material. So a lot of scope in this area. There's also shape dependent properties, as I told you, like this is very common. So in nutshell, what I would like to tell you is that when you talk about nanotechnology, it talks about improved properties and potential applications. So that is what is the highlighting summary of the nanotechnology. Now, when you say like these are the electron microscope, that is SEM and TM. These are used for observing the nanomaterial. Like the thing is, like we cannot see nanomaterial by naked eyes. That is very obvious, because whatever we see right now is with the help of the visible light, and the wavelength of visible light is say 400 to 1000. So the minimum we can see is within that range. So anything smaller than that, it's very difficult to see by naked eyes, nor with the it's difficult to see with light microscope, because light microscope, they also operate with the same wavelength. So obviously, if you want to see anything smaller than that, you'll have to use probes or electromagnetic radiations, will be having wavelengths smaller than the size of the particle. And what is nanomaterial? The universally accepted definition is like any material with at least one of its dimension less than 100, that is a nanometer. So if you want to see nanomaterial, you have to have probes or electromagnetic radiation with the wavelength smaller than at least 100 if you want to see somewhere in the range of 100. But if you want to see smaller particles like quantum dots, which are below say 10 nanometers and all these things, you have to have smaller wavelength. That is the reason why electron beam is used, and that has wavelength far smaller than, because electrons, everybody knows that the electron revolve around the atom, and atom is in the size of say like Armstrong. So obviously the electron and the electron wavelength, electron beam wavelength, are smaller than that. And so obviously that is used. So it's not only the electron beam. You can use any kind of electromagnetic radiation which are having smaller than that. Analogical example I'll give you is that if you have a pen with a broad tip, you won't be able to write small handwriting. So if you want to write small and beautiful handwriting, you'll have to have a pen with a small tip. So the analogy fits in here exactly. If you want to see nanomaterial, you have to have tips or probes which will be having like potential to screen on like smaller material. So it's not only the electron, but you can use lasers, you can use X-rays, you can use ion beams and all these things, and then many more. Those are still yet to be discovered. So we are optimistic that the new instruments will also come in the nanotechnology to probe all these things. Okay, so this is about the electron. Now coming back to the point, as I said, when you talk about nanotechnology, talk about improved properties. But what is green chemistry? Green chemistry is a design of chemical products and process that reduce or eliminates the use and generation of the hazardous substance. This is a standard definition, which in a nutshell, what I would like to tell you is that green chemistry, whenever we talk about green chemistry, it talks about chemical products and process. Like, it stresses mostly on the safety issues. Now the question is, why researchers are opting for green chemistry? That is very interesting, because that natural resources are depleting. Everybody might be knowing that the fossil fuels which are available, for the people on the earth, they are depleting, and eventually, like after some years, the fossil fuels and all these things, they'll be if you just imagine the rate at which the excavation takes place, just to take an example of iron and the number of buildings coming up, a time will come when we'll have no iron in the earth crust to exploit. So we have to pass this to the next generation also. So pollution is another concern, because more urbanization, more industrialization, pollution is on the rise. So we have to take this into account as well. The energy requirement is also growing with the growing population, growing industrialization, and the cost of energy is also increasing. So people are looking towards alternative energy. Economy, that is also another concern. Safety issues, time and labor. The cost of labor is also very high. So we have to look for greener approaches so that all these things can be addressed very well. So there are 12 principles of green chemistry. That is, those were formulated by Paul Anastas and John Warner. And so I was lucky to have opportunity to meet Paul Anastas in one of the conferences in Japan. And in a nutshell, I would like to tell you that green chemistry talks about safety or safety stuff, and nano about improved properties. When you combine these together, we can develop a sustainable nanotechnology or sustainable technology. The take-home message here is we need to learn a lot from nature. if you look at the human system, because human body has about 30 trillion cells, and all these cells, they are working very effectively. Although like chemical and biochemical reaction take in a body, but then take place in a body, but then all these side products, waste products are utilized in an effective way. So this is atom economy is maintained very well, and that's the reason why I'll tell you that we have to take a lot of learn a lot from nature. So that is the take-home message over here. Now, these are the 12 principles. I'll not go into the details. I'll just point all the key points here. The first principle, like prevent waste than to treat or clean. We also have a proverb that prevention is better than cure. So along this analogy, you have to see to that minimum waste is created rather than you need not worry about cleaning and all this. Convert maximum reactant material into final product. That is so when I'm talking about green chemistry, this is not applicable only to chemistry. This is applicable to any field, whether it's engineering or any damn field. So green has nothing to do with the color, but this is approaching or looking towards this technology from greener perspective, in the sense safety point of view. So it can be applicable to anything. Now you might have heard about a lot of green buildings and all these things coming up. So it's all about that. Synthetic methodologies should use and generate substances with little or no toxicity due to the human health, preserve efficacy and reduce toxicity. Preserve efficacy means you might have seen that pharma industries, they produce a lot of drug molecules and all this, and all these drug molecules, they have they mention expiry date. See, the thing is that means after the research and R&D, they have realized that the efficacy is sustained only to a particular period. So that is if that period is over, we are that is out of use. So ultimately we are not able to use the natural resources efficiently. So you should prepare drugs which will have long shelf life. So that is something which is, and reduce toxicity, that is without toxicity. Use of auxiliary substance like solvents, separation agents, this is more like chemistry oriented, should be made unnecessary wherever possible and innocuous when used. Minimum energy possible, probably the reactions conducted at ambient temperature and pressure. So that would be the best example. But wherever possible, you have to ensure that minimum energy is required and minimum heating is required. In many cases, you might have seen that in any synthesis process, heating calcination is a common process, like for preparing metal or metal oxide nanoparticles or any material for that matter, or heat treatment is a obvious process in most of the industries. But do you know what temperature if you heat, you get the desired effect which is required? So without understanding the background of it, we just mention that heat up to 400, 500. So if you know that the material can be can get the desired treatment after treating to 250, why you have to heat to 400? So that is waste of energy. So for this, online monitoring and all these things also will be useful. Then use renewable resources, because everybody knows now instead of using fossil fuels and conventional sources of energy, we are looking for non-conventional energy or renewable energy resources for generating energy and coping up with the requirement. So that is one thing. Avoid unnecessary derivatization, because for pharma industry, we see that if you want to prepare different kind of drug, derivatization and multiple step reactions are there. So we can look into the possibilities where you can minimize this kind of thing. Catalytic reagent as selective as possible. So this would address the earlier point that we can, if your catalysts are very selective, then you need not worry about so many multiple steps. Then products should not persist in the environment. This is another important point, because people have been using fertilizers, insecticide, pesticide to a great extent, but ultimately we don't have biodegradable pesticides eventually, and these pesticides do carry into food chain, and that's been a great concern for this thing. There's a place near Kolhapur, people have been using, because it's rich for agriculture. Everybody knows that it's a very popular place for sugarcane plantation, and then there are many vegetables. So people use excessive amount of pesticide, and that carries into the food chain. And there are many people who are suffering from cancer just because of this, because the pesticide persists and does not degrade with time. So that is another concern. So we have to develop pesticides which will be doing the job, and they'll degrade or perish. So that is very important. Analytical methodologies should be developed to allow real-time monitoring. So real-time monitoring, as I already told you, that if you are able to real-time monitor, if you're getting the desired reaction, say at a particular temperature after 2 hours or something like this, or say 30 minutes, why you have to keep the reaction for say 10 hours? So that is waste of energy. And I'm not talking about the reactions to be performed on the small scale in the labs, but I'm talking about the reactions which are performed on the large scale in most of the big industries. So that would be a, saving energies. So minimize potential for chemical accidents and toxins, and that's a common funda of the green chemistry. So in a nutshell, I would like to tell you green chemistry focus on safety issues, nanotechnology, and improved properties. So this total together can make a sustainable technology. So with this, I would like to tell is that, like, taking these issues in, like, we are trying to address some of the challenges in nanotechnology through green chemistry perspective, and we have performed some research work, and I'll share that work with you again. What are the potential challenges for nanotechnology? First is material manufacturing. There's a fundamental change in which the materials have been manufactured these days. People are looking for lighter, stronger, smarter, cheaper, cleaner, precise, high performance material. Self-healing, self-cleaning, all these kind of strategies people are coming up with, and a lot of examples I can give here where nanotechnology is coming up. You might have heard about Dulux paint, self-cleaning walls, wherein the paint is mixed with nanomaterial, and when you throw water, because of its hydrophobic nature, the water does not stick and it will remove the dirt particles. The same thing you can apply on the clothes. You can have self-cleaning clothes, and also with interesting properties and imparted to the clothing to generate the suits for the 21st century. Another area is energy, because as I said, rising demand in the energy and depleting natural resources, people are looking for efficient harvest of energy. People are looking for bio-based fuels like bioethanol, biodiesel, and all these things. Solar energy is one of the areas. Hydrogen storage. So these are some of the upcoming areas where nanotechnology is playing an important role. So clean air and water, that's another thing, because growing population and industrialization has increased greenhouse gases and pollutants that is significantly affecting the climate change. I mean, global climate. This has brought into picture the global warming issues, and then there's a fear that most of the cities at the sea level would be submerged after some years. So that is one of the key concerns, and cleaning and all this, the pollution is a need of the time. So people are taking seriously. There are deliberations on the international level to curb the pollution to a great extent, but still the process is very slow. The projected population growth and water consumption, we need water purification, because there are many places like Kolhapur, fortunately, is having enough water, but there are many places in India or even in Maharashtra where there's a shortage of water. So I'm suspecting that we should not, a time will come when we'll have to recycle and reuse water, just like what astronauts in the space station and all this thing. They don't carry a huge amount of water there. They use water very efficiently. They recycle and reuse water. So similar strategies have to be. We have enough water in and around the sea shores and all these things, but consumption of that water, it's very costly process, because the options for you obtaining clean water from there is like boiling. But boiling, we need excessive energy. Again, that also contributes to CO2 and like global warming. So another option is membranes. Like I heard that some other, like earlier speaker also talked about the membrane. So membrane filters, that's another technology where you can use it for purification water, and we can use a good amount of water from the seas and oceans, which we are having in and around India. So medicine and health, that's another area, because earlier a lot of advances are there in biomedical sciences. More diseases have been discovered. Earlier people just used to die without realizing what was the reason for the death. But now with the advances in biomedical sciences, at least we are able to discover what kind of disease are there, and there's a radical change in the way surgeries are being developed, diagnosis, drug delivery, and customized therapy, like systemic drug release and all these things. One point I would like to stress here is, although a lot of progress has been done, but there's still a long way. We are still a long way to go. I'll just give one example is that if you're having fever or cold, we usually take a tablet called paracetamol. That's very common. I'm not advertising for paracetamol, but just an example. If you look at the dosage, the weight of the tablet is somewhere around 1.5 gram, somewhere to 2 grams. But for the actual dosage of paracetamol is 500 milligrams. Okay, so that is a huge dose. If you look at the background scenario, when you talk about Avogadro number, the Avogadro number is 6.02 into 10 to the power of 23. For curing from any disease, how many molecules do you require? Because what do you mean by curing any disease? It is about curbing the misbehavior of the enzymes which are misbehaving, right? So like some enzymes are misbehaving, it is about curbing or restricting the enzymes or mobility or action of the enzyme. So for that we need maybe 100,000 or 10,000 molecules of the active drug. But when you are talking about taking medicine such as paracetamol, 500 milligram dosage, if you assume that and the molecular weight of a paracetamol will assume, it's just an example. If the molecular weight of paracetamol is 250, that means 250 grams of paracetamol would contain 6.02 into 10 raised to the power of 23 molecules. But just extrapolate the things. If you have 500 milligram paracetamol, it would have at least 10 raised to the power like 6.02 into 10 raised to the power of 18 to 19 molecules we are consuming. And what you need is just like say 10,000 somewhere around. So what are the other molecules they're moving? They're just moving in and around our body and creating side effects. So this is what you need to understand, and also look forward for target specific drug delivery and target. If I'm having a pain in my stomach, why should I have the drug molecule to move into my entire body? So this is like some of the hot area. People are coming up with interesting ideas. Also in cancer therapy, the conventional approaches for cancer treatment and all these things. Now people have come up with hypothermia, where we can treat cancer. It's almost in the clinical stages, and hopefully it'll be into use very soon. Another area is nanoelectronics and infotech, because scaling down of component like for high performance, longer life, and reduced cost. You might have seen that most of the computers were as big as a room. They have brought down to desktops, then laptops, and we have palm tops. This is how we are squeezing down the electronic gadgets. But does it mean that if you're making a computer from like desktop to laptop or palm top, even your smartphones and all this, they almost have all the features as a computer? So does it mean that the components required in the computer will be less? No, we still need all those features like motherboard, hard disk, RAM, and all these things. Now what has been done is this has been scaled down. By scaling down, we are consuming less material, but ultimately less material, but we are trying to make it very efficient. So how this is possible? By using the help, like taking the help of nanotechnology. Now the things have come, the lithography of we are using electron lithography in these things. Earlier the lithography or the patterning in the semiconductor was of the range of say 90 nanometer. Then eventually they came up to 60, 45, and now they are using electron lithography in the scale of say 15 nanometers. So that has scaled down, and the like all the components have been scaled down. But one more problem is that, like, if those from physics would realize that when you're operating some gadget, the heat produced by the the gadget during the flow of electron, that affects the performance of the gadget. Now here, when you're scaling down the nano gadgets on the nanoscale, obviously even small amount of heat is going to create a big problem. So heat dissipation or heat extraction is a big thing. So we are also trying to address some of these challenges from this thing. A lot of companies have poured a huge amount of money, to particularly the semiconductor industry, to address this issue by preparing efficient heat sinks. Okay, like this is thermo-Raman spectroscopy, and as I said, real-time monitoring. So what is done here, what we have done here is this is a coupling or hyphenation of TGA and Raman. So this is the one you can see below here is TGA. This is the Perkin-Elmer TGA6. This is schematic model, but then what we have done is a top loading TGA, that is thermogrammetric analyzer, where you can load the sample. So this is the laser, right? The laser is shown on diverted through the prism, and it is incident onto the sample. The backscatter radiation is taken, and that is taken to the Raman spectrometer. So what we are doing is that why we say it is thermo-Raman, because this is different from, like, you might have heard about temperature dependent Raman. So what is the difficulty in temperature dependent Raman and thermo-Raman? The thing is that when you talk about temperature dependent Raman, if you want to study the physical and whatever properties of the material at a particular temperature, what we usually do is we take a material, we heat at say 200 and bring to Raman spectrometer and then measure the spectra. By the time you bring from that heating zone to the Raman, it's almost at the room temperature. So you are not able to understand the exact physical chemical properties of that material at that particular temperature. So by having this, we can simultaneously record the Raman spectra of that particular material at that particular temperature. So we can literally understand what is the material, what are the properties, what are the at that particular temperature. So that is the beauty of the material. So this is the hyphenation, and what modification I've done, this is the top lid over here that is converted, that has been changed with the glass lid. So the laser beam shines from and passes from this lid, and then the backscatter radiation is taken to the ground. So we have to check the versatility and the application of this. We have published so many papers. We have used Raman spectroscopy for understanding polymorphism, structural like phase transformation, chemical reactions, and all sorts of examples we have tried. it's not only this, we have also coupled this thermo-Raman spectroscopy with understanding the electrical property. What we have done is we have prepared a pellet of a material, and then we have coated 2 electrodes from both the sides, and the laser is shown from one side and the backscatter radiations are taken. So we by this method, we are able to record structural properties with the help of Raman, thermal properties with the help of TJ, and electrical properties with the help of the LCR meter. So we can have simultaneously you can take with all the properties in one experiment rather than doing several different experiments. So this is the analytical example why like we have used real-time monitoring for the formation of zinc oxide. Because if you want to prepare zinc oxide, like zinc acetate dihydrate is a common precursor, and by heating zinc acetate dihydrate, you can get zinc oxide. That is very much known. But apart from this, if you want to prepare any nanomaterial, heating calcination is inevitable step. That is a very common step, and calcination is inevitable as in this case as well, because organic species on the surface and agglomeration, these are the problems which has to be addressed. So purity, size, and size distribution of zinc oxide is also necessary. Why we came up with this work is because when we saw one report in the literature, there was a Japanese group. They showed that the TGA thermogram of zinc acetate dihydrate, and if you look at this TGA thermogram, it shows 100% weight loss. It means that when you talk about 100% weight loss, there is no zinc oxide form, so which is contrary to what we have observed. So this is the TGA thermogram we have shown here, and it shows that 30% weight is remaining. So when you take 100% zinc oxide and zinc acetate dihydrate, we get 30% of zinc oxide. So we did a real-time monitoring of this using Raman spectroscopy. So this is the Raman thermo-Raman spectra at 25 degrees Celsius. So this is characteristic of zinc acetate dihydrate. So actually we are able to record Raman spectra at every degree interval, but for the convenience, we have only reported a few of them for better understanding. So if you look at this, if you're heating the material at higher temperature, eventually there's a significant change in the spectral properties, and like this spectra at 25 degrees indicate zinc acetate dihydrate, and then the one at 160, it indicates anhydrous zinc acetate. Eventually it is converted into zinc oxide at the end at 250. So if you are able to get zinc oxide at 250 or 240, why we have to heat at 400? Because there are many reports in literature. They say that heating zinc acid dihydrate up to 400, 500 to get the zinc oxide. So, but if you are getting zinc oxide at 250, we need not heat at high temperature. So that would save energy. So look at this. This is the right side. This is a thermo-Raman spectra. If you look at this, this is the TGA curve over here, and the another curve which is indicated by 950, that is the peak, the intense peak in the thermo-Raman. So the intensity in of variation of that peak is monitored, and that almost agrees to that of the TGA thermogram. Although the working principle of TGA and Raman are entirely different, but we get reliable data. Another peak over here, that is the peak characteristic of 514 centimeter inverse. That is the characteristic of anhydrous zinc acid. So initially the intensity is low. Eventually, when the anhydrous zinc acid is formed, the intensity increases and eventually goes down. Another peak is 437. That is characteristic of zinc oxide. Initially the intensity is low. Eventually it increases. Now, if you look at the cross section over here, the cross section is at 250. So this graph, and in comparison with the TG and thermo-Raman, we can understand that we can get to at 250, you can get the desired zinc oxide. So this indicates that when you heat the material at 250, you can get zinc oxide. So we can save a lot of energy. So by using this, so this is a real-time monitoring. This can be applicable to any kind of material synthesis process. So we can understand from this. So this is the SEM image of the starting material, that is zinc acid dihydrate. So when you're heating the material at slow oxidation, slow heating rate and in presence of oxygen, we get spherical nanoparticles of the size of say 40 to 50 nanometers. So and these, if you are heating at a faster rate, we get irregular shape, rods, wands, and all these things. We can also produce the same size nanoparticles when you're heating in air or nitrogen, but there's a possibility of impurities here. On the right side, if you see that slow heating in presence of oxygen, you get very good pure zinc oxide nanomaterial. This is the TM image, which shows that the particle size is very small. That's around 40 to 50 nanometers. This is the SED pattern, that is selected area electron diffraction, and the lattice fringes, which shows that the material is crystalline. We have also analyzed this by FTR, which shows that this the one below here shows the zinc acid dihydrate spectra, eventually anhydrous zinc acetate, and FTR. Now, having done the analysis or comparison between thermo-Raman and TG, we also wanted to try whether we can have the similar kind of impact or similar kind of data from TOFSIMS. Now, what is TOFSIMS? That is time of flight secondary ionization mass spectrometry. This is almost like SEM. In SEM, what we do is we bombard primary electron and The secondary electrons which are generated from the material, those are responsible for the like the 3D image. Here, what you're doing is you are bombarding the primary ion beam, like gallium or different kind of ions could be used here. But here in this particular work, we have used gallium ion beam, and we are bombarding into the material, and the secondary ions, which are the characteristics of the material, would be generated. So here, what we did is that, but in TOF-SIMS, because that is ultra high vacuum, this is the analytical chamber. The analysis performed at very high vacuum, and the recording one spectra takes about 200 seconds. So obviously we could not record Raman like TOF-SIMS spectra at every degree interval. So what we have done is that we have recorded the TOF-SIMS spectra at an interval of 25 degrees. So, but here you have shown only 25, 150, and 300. That is representative of zinc acid dihydrate, anhydrous zinc acetate, and zinc oxide. If you look at the spectra here, you can see the peaks associated with zinc. There are isotopes for zinc, that is zinc 64, zinc 66, and zinc 68. So these are the isotopes. So, and these were the intensity of these peaks were recorded as a function of temperature. And if you look at this, this is the TGA thermogram and the DTG. Here is the TGA thermogram, which is compared with thermoraman intensity, and this is the peak, which is like the intensity variation peak as a function of temperature obtained from like TOF-SIMS. If you look at the ion from zinc 64, the intensity drops down somewhere around 100. That is associated with the dehydration. Then there's a change in intensity from the temperature, say 100 to say 220 or 250. So that accounts for loss of acetate group, and then zinc oxide is formed. The same trend is observed in zinc 66. So if you look at the working principle of TGA, Raman, and TOF-SIMS, they're entirely different. But we still get comparable data. Even this TOF-SIMS indicates that we can get the desired material at 250, that is zinc oxide is 250. Now, everybody knows, like, this is another work we have done, ultrasound assisted. This is a very highlighted work of ours. Ultrasound assisted coating of zinc oxide and titanium oxide and silver nanoparticles like on the paper surface for the use as antibacterial wallpaper. Everybody knows that zinc oxide is one of the extensively explored material for different applications. Like substrate, it has been used as substrate for functional coating, UV inks, e-prints, optical communication for security papers, protection barriers, portable energy devices, sensors, and even antibacterial wallpapers. But so far, most of the like zinc oxide coating was done on thermostable substrate, that is, say, stainless steel or some kind of material. So here in this work, we have developed an approach wherein we can coat the zinc oxide nanomaterial onto paper substrate or cloth surface by using room temperature approach. So this has potential applications in different things. Now what is done here is the zinc oxide which is required, which was prepared from sol gel method, that is dispersed in ammonium hydroxide. So what is the pH was maintained at 80 degrees. So what happens is that when you disperse that the zinc oxide in ammonia, so this is like the zinc oxide you can see in the image over here, and the ammonium ions tend to get absorbed onto the surface. So what happens is that at the core you have zinc oxide with the ammonium ions at the surface, and like ultimately when you like start the ultrasound, the particles, the droplets will be formed. They'll be moving upward, and they'll gallop and cover the cellulose fiber, and they'll get adhered to it. So if you look at the reaction here, like paper is, everybody knows that paper is made of cellulose. Cellulose is carbohydrate, and there are a lot of OH group on the surface. So this is how zinc oxide gets bind onto the paper surface with the help of OH functional group. So this is a chemical binding which ensures that this is stable binding, unlike physical binding. So when you heat the paper, the ammonia is lost, and then you get zinc oxide bound on the paper. Like this is the like topward coating approach, because here, like when you start the ultrasound, with the help of sound waves, the particles would move and they'll bind onto the paper. If they don't bind on the paper, they'll fall down. So we are not consuming more material, and also loss of and the instrumentation cost is also less. If you look at the right side here, this is the blank paper. A lot of surface defects, because while the paper manufacturing process, a lot of defects are obtained. But if you sonicate the paper in presence of, like, say, zinc oxide dispersed in ammonium hydroxide, only for 5 minutes can have uniform coating of zinc oxide. So this work was also highlighted in US Defense magazine from the perspective that they can generate suits for the 21st century, for the fact that these nanomaterials, like these nanomaterial coated clothing, could be used as like antibacterial, antimicrobial material, and we should prevent the soldiers from biowarfare. Now, this work was highlighted in Chemical Technology Nanoworks. I already told you that it was also highlighted in US Defense Magazine in one of the issues. Now, this is like, after sonication for 5 minutes. 5 minutes of sonication is more than enough, and you get uniform coating onto the paper surface. This is after 10 minutes, and this is after 30 minutes. What happens is with the time increase in time, some of the nanoparticles is entangled, and more amount of zinc oxide is deposited in the paper. With 30 minutes is more entangled. Now, if you look at this first image, 5 minutes of sonication is more than enough. And the best part of this coating technology is it selectively binds the cellulose fiber. It does not fill the interstitial wall. So if it does not find OH group, it will not bind to it. So that is the thing. So by this way, we can, less amount of material is used. There are other ways of depositing the zinc oxide onto paper, but you can make a slurry. You can put that, paintbrush technology is there, then Dr. Blade technology. But then what will happen is that the material will fill into the voids of the defective paper or the network, and then we'll be consuming more material. So when we published this paper in Grain Chemistry, the reviewers asked that, there's a possibility that the nanoparticles inside the beaker would collide each other and agglomerate. So this is the image we have shown below here after 10 minutes, 20 minutes, and 30 minutes. There was no agglomeration. Why there was no agglomeration? Because I already told you the zinc oxide is at the core, and it is coated with covered with ammonium ions. So everybody knows that like charges repel each other, and that's the reason why it prevents agglomeration. So we can still retain small size nanoparticles in this medium, and we can use it for multiple processes for deposition. Now, coming back to the point, this coating technology is simple because we are not using any other costly equipment. It is green because we are using water solvent and zinc oxide. It is economic. No costly equipments are required. Nanoparticles coat the fibers. I already told you that when the nanoparticles come up, go for upward coating, it only coats the fibers, and if they are not coated on the fiber, they'll fall down back. It avoids filling interstitial voids that consumes less material. Then we are using water solvent. Then environmental friendly because unlike spray coating, because spray coating could also be used for coating on the paper, but then that would that requires viscosity, costly equipments, and also polluting the surrounding environment. You might have heard about spray painting and all these things, which we have to take safety precautions for. But in this case, it's a upward upward coating approach. So if the particles don't bind to the fibers, they'll fall back into the medium. So that's how we are not wasting any material. It is environment friendly. It avoids waste. I already given an example, and it certainly has advantage over spray and bench coaters. Now, having given that idea, when I claim that the nanoparticles selectively bind the cellulose fibers and does not form multiple coating. So what we have done is we have this was the methodology we have developed for understanding how much zinc oxide is coated onto the paper. So this is after 5 minutes, 10 minutes, 15 minutes, 20 and 25 and 30. So what we have done is we have coated the paper for all these minutes, and we have taken small piece of it and measured the TJ. Now in TJ, what will happen if the paper is purely made up of cellulose? Then what will happen when you burn that paper up to say 600, 800, the entire paper will decompose and the loss of weight will be 100%. Now, and if the zinc oxide is coated, then what will happen? The paper part will burn off, but zinc oxide will not burn. So from the difference in weight, you can find out how much zinc oxide is coated onto the paper. So if you look at this graph in the first one, there's a TGA thermogram of the blank paper, which shows that almost 91% of weight loss is there, and there's 99.2% weight is still remaining. That accounts for fillers and binders or whiteners, which are used in the paper manufacturing process. Now, in the other two graphs, you can see for 10 minutes and 30 minutes, there's a difference in weight you can see. So that accounts for 14.3. So what it means is that if you sonicate that along with the paper for 10 minutes, we can have 14.3% of zinc oxide coated onto the paper. Now, ideally, if it is multiple growth or multiple layer deposition of zinc oxide, for whatever amount of zinc oxide is coated for 10 minutes, for 20 minutes, it should have been doubled, right? Or 30 minutes, it should have been tripled. But even after 30 minutes, we have seen that the coating of zinc oxide is 17 point. What it indicates that there's no multiple coating. So, and if you look at the graph insert over here, for 5 minutes, the loading of zinc oxide is somewhere around 13%. For 10 minutes, there's a slight increase, and eventually the increase is not significant. If there would have been a multiple layer or deposition, the graph would have been a straight line increase in incremental, and with a subsequent increase in the zinc oxide loading. But that's not the case. This proves that zinc oxide is not multiple loading, and it's there. So what we did there, we also recorded XRD spectra to understand this. The blank paper spectra, XRD spectra is here. You can see the calcium carbonate analysis, which I use as whiteness. In the zinc oxide coated, you can see the zinc oxide characteristic peak. We also took top seams images to understand the uniform deposition and distribution of the nanoparticles in the paper. So this ensures that the coating was done. Now, like when everybody knows that zinc oxide is a very good photocatalyst, and also it shows very good interesting properties. So we also investigate the antibacterial properties of zinc oxide coated paper, and it's in FIRDI, that is Food Industry Research Institute. It was in Hsinchu, Taiwan, and we found that zinc oxide coated paper obviously showed very good antibacterial property. This is very obvious because zinc oxide is known to be photocatalyst. It will show antibacterial property. But during our research, what we found is that like zinc oxide coated paper also showed antibacterial property even in absence of light. So that was very promising. And when we went to the details of it and did some experience, what we realized that zinc oxide, the paper is made of cellulose, and it's a carbohydrate. Typically, it has a tendency to absorb moisture. So this moisture reacts with zinc oxide and tends to form peroxide. So the peroxide has very good oxidizing property that attacks bacterial cell wall, and then we get the antibacterial property. So when we realize that we get antibacterial property even in absence of light, then we came up with the idea, if we coat these kind of like zinc oxide coated paper as a wallpapers, then we could have interesting benefits. Now, if you look at the thing in most of the hospitals, the disease aggravation is not because of the disease, but it's because of the bacterial infection. But if you have if you have this wallpapers coated into the hospitals, you can minimize the increase or aggravation of the disease. Now, for cleaning purpose, what we use is that we use disinfectant to clean the flooring. But what about the aerial bacteria? So if you have this kind of antibacterial wallpapers coated into the hospitals, we can minimize the bacterial loading into the hospitals and curb or minimize the bacterial infection as well. The same thing could be applied in your homes, where we can. It's not only the bacteria, but also it can degrade the VOCs and TOCs and all the pollutants. So you can have a thin layer of zinc oxide coated wallpapers coated on, or you can have thin layer of zinc oxide directly sprayed onto the wall, which can get additional benefits from this. It's not only that, we also coated titanium oxide onto paper. We have very good data for this. It has much better activity. This still is not published, because rest is all same, the data, but it has been improved properties. Another area, it's interesting stuff. Everybody knows about carbon nanotube. Carbon does exist in several different allotropic forms. That's carbon, then it's diamond, graphite, fluorine, nanotubes, and all these things. Carbon nanotubes are one of the most explored material, later on, like graphene. But why that was the most explored material? Because if you look at the properties of the carbon nanotubes has strength almost 100 times that of stainless steel, right? So that is the interesting. Plus, carbon nanotube is very light. People have been using carbon nanotube as tips for sensors and the AFM tips, and a lot of interesting applications because of the electrical conductivity. Making a blend of carbon nanotube and polymers, they have found to be very interesting, because there's already rackets, tennis rackets, which are made from the polymer CNT composites. A lot of components in the aircraft nowadays have been used with the help of this composite. You might have heard about Kevlar fiber, which is a composite of polymer and CNT. Like the fiber or the cloth which is made is as thin as a terracotta cloth, but it has the ability to prevent the penetration of AK-47 bullets. So nowadays, most of the US commandos, they use these kind of jackets which are lightweight, and plus they can prevent them from the attacks of bullets and all these things as a safety purpose. Unlike people in the early days, they used to use armors which are made from metal, which are very heavy, and that would consume a lot of energy, like you're moving from one place to the other. So we want lightweight material plus the material with the required strength. So people have been exploring all different applications of carbon nanotubes in various different technological aspects, including sensors and all these things. But here we have come up with something which is very different. Everybody knows, the topic here is carbon nanotube as artificial molecular chaperone. Now, for those from bio background or little idea about biology, they would realize this and appreciate from the fact that protein aggregation and amyloid formation, that's a topic of great concern, because in most of the biotech industry, protein purification and all these things are a regular process. But if the protein are exposed to adverse condition, the protein would aggregate and never come back to the native state. That they lose their natural structure, and they form a denatured structure, that is and never fold back to the state. So similar protein aggregation that is observed in most of the pathological condition or disease like amyloids. So similar kind of diseases are related to Alzheimer's disease, Parkinson's disease, mad cow disease, Huntington disease. What happens in these cases, the beta amyloid proteins, they tend to form aggregates, like they cross-link, they form aggregates, and they form protofilament like this, and then the amyloid fiber. These fibers, they break down, they go into the neuron cells and damage the neuron circuitry or neurofibrillary system, and then this leads to a loss of memory. So a lot of disease, neurodegenerative disease are related to this because of this kind of aggregation. Now, in normal case, we have molecular chaperones in our system. These are also called as helper protein, which help the misfolded protein to fold back to the native state. But depending upon the different size of the protein, the molecular chaperone size also varies. But there's an issue of the stability of these protein, and like the solvent applicability of this protein to wide range is questionable. So what we thought is that why not prepare like CNTs as artificial molecular chaperone. So we came up with the idea that why not prepare artificial molecular chaperone with the help of CNTs. If you look at this, like similarities between carbon nanotube and molecular chaperone. This is the Groyal 57 kD molecular chaperone. If you look at the morphology of this and the morphology of CNTs, this is a direct comparison of this. Both have hollow cylindrical structure, with the Groyal having like say 13.5 nanometer diameter, and the CNTs can be varying from 2 to 30 nanometer with a lumen size of say 2 to 8 nanometer. Height is 14.5, and like you can have the length of carbon nanotube controlled anyway. So what we thought is that CNTs, like they are very highly stable, and they can be chemically manipulated to mimic that of the the molecular chaperone. So carbon nanotube has aided in preventing protein aggregation and folding. It's a new concept and has no precedence. We published this work in Carbon in 2007. Now, for this experiment, what we have done is we have prepared carbon nanotube using arc discharge method. It's typically arcing method, just like welding in argon atmosphere, and we purified these CNTs with the help of acid treatment, and this is the TM image of that. So what we for like test purpose, what we have done is we have taken FGF protein, that is FGF1 protein, human fibroblast FGF1 protein, and we treated with TFE, that is trifluoroethanol, and we found that it tends to aggregate. So, but when we put that along with the CNTs, it does not aggregate. So that was interesting. So for this understanding, we did further experiments. Like initially, what we did is that we varied the amount of CNTs and we fixed the concentration of the protein. And what we found is that when we change bring the concentration of the CNTs up to 40 milligram, the aggregation decreases. So in this, what we observed is the absorbance at 350 nanometer. Optical density was measured. And in the second experiment, you can understand that in the presence of CNT, there's no aggregation. But when there's no CNT, there was severe aggregation. But with the presence of CNT, there is no aggregation. So we also propose the mechanism of like how it happens. So in this case, either the protein get absorbed onto the surface of CNT or get encapsulated in the CNT, which prevents aggregation. So a lot of work is going on in this direction about preventing aggregation. Another area, as I said, utility of superlative water in nanotechnology. Everybody knows that water is indispensable for life, right? But water, when you heat at high temperature, that is 374 degrees Celsius and pressure of 218 atmosphere, that is above the critical point, it becomes superlative. Ideally, if you look at water molecule, water does not exist in the molecular state, right? Because if you look at water, the components required is hydrogen and oxygen, right? Hydrogen also gaseous state, oxygen also gaseous state. So gas plus glass should be gas, but water is always in a liquid state, from the fact that the water molecules are linked through hydrogen bonding, and it forms a longer chain. And you know that the chain length increases, viscosity increases. Obviously, the water is in the liquid state. Water exhibits interesting properties significantly different from that of the ambient water. That is, the density of superlative water is like say ambient condition. Density of water in ambient condition is 1, but then it changes to 0.07 gram. Viscosity is lower than the ambient condition by a factor of 25. Static dielectric constant that changes 78 at ambient condition, which changes to 1 to 3 in superlative condition. and the ion dissociation product also changes. So these are the images. You see this, the image photograph below. This is the water in the ambient condition. This is subcritical state photograph, and the photograph taken at stable state. You can see that the interesting properties can be achieved. So we have used the properties of stable water for purification of CNTs. For those who are working in the field of carbon nanotube, they'll understand that if you are preparing carbon nanotube, there are a lot of impurities in the process of making carbon nanotubes. A lot of metal impurities like carbon anion and a lot of carbonaceous impurities are there, and purification of the mixture to obtain pure carbonate is a normal process. And like in most of the cases, we use strong acids like overnight reflux reflection and all these things for getting the pure CNTs. So here you can see this, let's say raw CNT SCM. This is the raw CNT TM, and then the purified CNT. Here we have used water for purifying the CNT, because we have taken the advantage of oxidative property of supercritical water for purification of the CNT. So this is a typical setup we have used. This is the syringe pump for pumping water. This is the reaction cell wherein we have put the raw CNTs, and there are two knobs on the other side to prevent the inlet and outlet. This is the pump which was made from Supelco, and we have pumped that water into this. And this is the vibrator furnace where we have heating and vibration system. We can purge nitrogen and oxygen. Nitrogen was used for purging out the material which was put into the cell. Oxygen was used for creating oxidative environment here. So that is the thing. We can use this soluble water for purification of carbon nanotube, opening of carbon nanotube, and also thinning of carbon nanotube. So if you want to make small, less walled carbon nanotube, we can use oxidative nature of soluble carbon dioxide, so soluble water, to remove the multiple layers, and we can have thin layer of CNTs. So because if you look at the carbon nanotubes, at the tip there's a pentagonal ring. So those are the sites which are prone to oxidation. So usually everybody knows, because of the angular strain, like pentagonal ring and the heptagonal ring, those are the sites which are prone for oxidation, and we have taken advantage of this in purification and also opening of CNTs. So we can open the tip of the CNTs with the help of the carbon. So by maintaining the condition, like say 400 psi and 400 degrees Celsius for 30 minutes in absence of CNT and like oxygen, and in presence of oxygen, you can see that you can thin the carbon. If you look at this picture here, the multiple layer of CNTs have been oxidized, and also thin layer of CNTs can be found. So we can have the reactions performed in presence and absence of oxygen. Another reaction, what we have done is, if you take, everybody knows that silver is known to be a very good catalyst, and like in this experiment we have filled silver nanoparticles in situ inside the carbon nanotube. What we have done is we have taken Ag2O. It's like it's thermolabile, and at 227 degrees Celsius dissociate to form silver and oxygen. So what we have done is that we have put the CNTs along the CNTs. Like the purified CNTs were in the reaction cell, we have added silver oxide in that. So with the help of supercritical water, the silver oxide is broken down into silver particles, and eventually when the tip of the carbon nanotube is open, the nanoparticles go inside the CNTs. This is the schematic here. These are multi-wall carbon nanotubes. Because of the oxidation, the tip is open, the nanoparticles are formed, and they are pressurized or put inside the CNTs. Now, the interesting part here is that we are very much optimistic. So if you look at these carbon nanotubes with one tip open, so what will happen? These will be like nanotest tubes. So far we have been performing chemical reactions in the earlier, gram scales. Then we came up to milligram. Now we are performing the chemical reactions in the microgram. We are very optimistic that future is all in store for performing reactions on nanoscale and monitoring this. Right now we don't have the facilities or tool to monitor the reaction on nanoscale, right? But future, there'll be tools with which we will be able to monitor the reaction on nanoscale. Now if you look at this carbon nanotube with one end open, it will be like a nanotest tube or a nano reactor, wherein we have nano catalyst silver, and then we can induce any other catalyst, and the reaction is going to be performed, because this is the time when we'll be running short of natural resources. So these are nano reactors for the future. By changing the parameters of these things, the supercritical water, we can have all the different morphological structures of the silver. So all these are the images, and by changing the parameters we have seen. This is another interesting work because this work was done by Murli Shastri. Like he was a scientist from NCL, Bhatnagar Awardee. What they have done is, biological synthesis of gold nanoprism. This was published in Nature Material. They have taken lemongrass extract. Okay, they boiled the lemongrass leaves, and the extract was treated with auric chloride, and they found that they could get very good triangular prism. Now everybody knows that like gold nanoparticles, gold prism, they have interesting application for SIRS in ramen. They have in hypothermia or all variety of applications. It also prevents the penetration of IR radiation that keeps the interior cool when you put this kind of thin films onto the windows. So this work was done by Murli Shastri. When Murli Shastri had been on visit to Taiwan, he wanted us to use thermoraman spectroscopy to understand how the nanoparticles grow. From the point the auric chloride was added into the the lemongrass extract, how the nanoparticles, the ions, they get reduced and they club together, agglomerate, and then they form triangular prism. So unfortunately, we did not find lemongrass in Taiwan, so we came up with a new strategy. I took the advantage of the botany background, and we came up with this study. Everybody knows that green applications, green biological of gold nanoparticle would be interesting because there are potential application absorbers for near infrared radiation. It can cool the interior, hypothermia for cancer cells, SIRS, and sensors. Now, when you are looking for gold nanoparticles for biomedical application, there are, the best option would be using the nanoparticle synthesis using biological approach, and that too from eatable stuff. Now, I'll tell you that gold nanoparticles could be synthesized using chemical methods as well. But if you synthesize by chemical method, it is always possible that surface adsorbed molecule onto the surface of the nanoparticle would create problems and may induce toxicity as well. So, but if you're preparing the nanoparticle using biological medium, and that too from eatable stuff, that would be something interesting. Okay, and from that perspective, our was interesting. What we have done here is, we have taken gram beans. Okay, so we've cleansed gram beans is typically very common in India. This almost every household, they soak these seeds for preparing different kind of vegetables or something like this. So we have taken these seeds, we have washed them and soaked them in water, right? And then remove those seeds. After removing, after 6 hours, the seeds still do retain germination property. Or germination, I can see the sprouting of the beans here, and the extract which was obtained here, that is a common kitchen waste, right? If you soak this seed, the leftover water, that is a kitchen waste, and you usually throw it. So what we have done is we have taken that extract and we have treated the auric chloride, and you get very good triangular prisms of gold. And if you look at the image here, the edge size of the triangular prism is around 6 micrometer, and the thickness was 50, say 25 nanometer. So thin, slates of triangular prisms of gold nanoparticle you can get from this. Now, the interesting thing is that this is common kitchen waste. But what we have taken is that only 1 ml of the extract and treated with auric chloride, that is 1 millimole, and you could get triangular prism. And how it is different? We are not using invasive strategy. Unlike Murli Shastri, what they had done is they had taken lemongrass, they boiled the leaves, and the extract was obtained. So they are destroying the leaves. Here, we are not destroying. We have soaked the seeds, and the seeds do retain germination property. The extract which was obtained, that was taken. So that is again a non-invasive strategy for synthesis of gold triangles. So here we have.
Sir, excuse me, sir. Anil, sir. Sir, next resource person is wasting. Time is up, sir.
Okay, thank you. We'll just quickly wind up.
Yes,
so these are the triangular prisms we have prepared using this thing. The particle size were very big. We also try to understand the molecules from what are the molecules present in the extract which are contributing to this. We also prepared gold and silver nanoparticles inside the seeds. And apart from that, we also prepared bimetallic alloy, gold silver alloy using the extract in the extracellular medium. We also tried all different seeds on the leguminous species, and all the data is very interesting. I think I'll stop here. Thank you very much. So I would appreciate questions.
Sir, good morning. Can I ask questions, sir?
Sure, no problem.
Sir, Parshuraman sir, good morning, sir.
Good morning, sir.
Good morning, sir. Sir, Parshuraman sir is from IACB, Calcutta, sir. So I want to introduce Dr. Anil Gule, sir.
Thank you very much, sir. Sir, it's very interesting and huge amount of work and very interesting results, actually. I just couldn't control myself, from thanking you. And Thank you very much, sir. And a couple of questions actually, with the
Sure.
permission of the organizers, we are running out of the time actually, of course.
Yes, sir.
So this is regarding the thermo-Raman spectroscopy actually. Sir, actually, is it possible to analyze the organic molecules which are undergoing change in the geometry when we apply the heat actually?
Yeah, that is very much possible, because that's what we have done, you know, phase transition, all these kind of structural transformation, because Raman spectroscopy, as long as they are active in Raman active, they
Yes,
can
sir.
be.
Okay. Okay.
So all
So
these
how
things,
much?
so we, as I told you, like we have, we can check some of our papers. We have tried all the different kind of. So we can also monitor the reactions. You know, this is possible in gas state, liquid state, and also solid state. That is only the cell which contains that. You know, like for liquid monitoring, we'll have to use different cell. Here it is totally, it's all controllable. I mean, we can have different cells for all these things for monitoring. Solid state is bit easy, but for liquid and all these things, you have to be specialized cells could be used for that.
Yes, sir.
Material you need, sir, to do. Suppose, you know, one experiment from starting from 25 to, suppose the temperature is not beyond 200. How much of material is required, sir, to run the experiment?
No, it depends on, like, the laser spot is very small. As long
Okay.
as the material is good enough to cover the laser spot, few milligram is more than enough. I mean,
Fine,
like, you
sir.
know, depends. Small size cell is enough.
Okay, sir. Okay. Thank you very much, sir. I'll contact you.
Sure,
Sir,
sure.
the another one is the TOF sim. Actually, we
Yeah.
also teach, actually, we have taught up to multi-TOF, ESI mass, and then, you know, even ion trap, triple cord, all those
Yeah.
things. But TOF seems to be slightly different in
Yeah,
the sense that actually, is it related to something like MALDI or something beyond that? And how it is different, sir?
MALDI is, you know, because that is typically matrix assisted laser desorption ionization, wherein the laser is used for shining onto the matrix. So the matrix molecules are excited, and then the energy is transferred to the analyte molecule, which generates the ions of the analyte. So in general, the ratio of analyte to the matrix molecule is like, you know, 1 is to say 10,000 or even more. That varies.
Yes.
That is
actually preventing. That is
Yeah.
preventing the district or direct contact with the laser,
exactly.
so that the material will be, you know, just, you know, decomposed.
Yes, it is soft ionization technique.
Soft
Here,
kind of.
this TOF SIMS is particularly used for inorganic or solid materials, and this is widely used in semiconductor industry, because in Taiwan, like, you know, there were 3 to 4 TOF SIMS, and one was in our lab. So that is the advantage we have taken here. And, like, you know, in this case, the ions are bombarded. So high energetic ions are bombarded onto the material, and secondary ions which are generated, that is the characteristic of the material. So here there's a possibility of destruction. We can also go for depth profiling, wherein we have another cesium ions for scooping of the material. So we can analyze what is the property or what is that inside along the depth of the material. So that is interesting.
I got it, sir. Cesium and galliums are used to generate the primary ions, correct, sir?
No, cesium is a heavy ion. So usually they are used for scooping or for depth profiling. Gallium, bismuth, and all different, like, you know, gold ion, those are used for analysis. Typically.
Okay, sir. Thank you.
So
titanium and zinc oxide particle size. I'm sorry, sir. Thank you, sir. So zinc oxide and titanium oxide, and what is the particle size you have used actually nanomaterials, sir, for putting?
So, you know, like what we have used is somewhere around 8 to 10 nanometers.
Okay.
In that experiment. But, you know, by using thermo-Raman spectroscopy, by thermal decomposition process, we get the size of, say, 40 to 50 nanometer.
Okay, sir. Okay. Thank you very much, sir.
Thank you very much.
Thank you, sir. Thank you very much for your nice presentation, sir. Anil, sir.
Thank you.
Sir, a PowerPoint presentation is going on, sir. You please.
I'll just stop sharing.
Yes, sir.
So thank you, sir. It's a great topic, and thank you. It's a great topic and presentation. It is really informative, and you have enriched us with new ideas by giving an excellent coverage on the topic. Thank you so much.
Thank you, sir. Thank you very much, sir. Sir, Murugan sir.
Yes, sir. I'm there. I'm there. Yes, sir.
Yes, sir. Sir, I'm searching a photo. Yes, sir.
Yeah.
Yes, sir. Sir, good morning, sir.
Yeah. Good morning, sir.
Good morning, sir. Good morning,
I
sir.
hope
Nice
you
to
can
meet
see
you.
me. Yeah.
Yes, sir. Ma'am, HOD ma'am. Sir, Vijay sir.
Sir.
Vijay sir, mute.
Sorry.
Sir, next session start பண்ணிடலாமாங்க sir?
Start பண்ணிடுங்க.
Thank you, sir. Madam, WS ma'am, please take on.
Yes, sir. You can start.
Thank you, madam. Thank you.
Now we will turn the time over to our next speaker, Dr. P. Murugan, Assistant Professor, School of Management Studies, University of Hyderabad. Dr. P. Murugan received his doctoral degree in Management Studies from Anna University and has more than 10 years of teaching experience. He is having expertise in multivariate data analysis techniques, mediation analysis, moderation analysis, covariance, and partial least square based structural equation modeling, latent profile analysis, and item response theory. He has an impressive list of publications, and his papers are published in SSCI and ABDC listed journals. We are so honored and privileged to have him with us today, and I now invite him to present on the topic, online teaching with web conference tool, which is the need of the hour. Please, sir.
Thank you, ma'am. Thank you so much for your warm introduction. Thanks to Professor Muthukumaran sir for coordinating this, wonderful job in terms of organizing series of webinars. Thanks to Presidency College Principal and other colleagues related to organizing this program. So I hope you can hear me. Let me share my screen. So for the next 45 minutes, what I'm planning to cover here is very simple thing. Already, of course, you are using the Zoom platform to listen something. So similarly, I'm going to show you different open source platforms where you can do the online teaching. That is what I'm going to do now. So if you see, especially this COVID duration, whatever maybe the workshops or webinars or even our regular online teaching, everything is going through online mode. So I want to communicate three different topics part of this web conferencing tools. One is how you can use different web conferencing tools for your online teaching. And then second one is how you can record your own video lectures for your students. For example, now we are conducting this live webinar session. And about 45 minutes, I'm going to explain something. If you share the same 45 minutes content with your students, I don't think so they are motivated enough to watch the entire 45 minutes content. So you can create some short videos, maybe 10 minutes or 15 minutes videos for each and every topic, like a capsules you can give it to your students. So that is the second component I'm going to show you. Even with the help of the same platform, the Zoom or maybe Google Meet, it can be anything. With the help of that, you can also record your own videos. And there are some different open source packages also available. Even with the help of that, you can record your videos. That is what now we are going to discuss. Now, in terms of understanding web conferencing tools, there are plenty of tools are available in the literature. So now I just want to show you a tool that is something free to the public. That is nothing but Gmail. So either you can have free Gmail account or you can have G Suite based Gmail ID. I don't know whether Presidency College is having G Suite based Gmail ID or they are using normal Gmail ID or some other domain. But for example, this is my personal Gmail ID. This is my personal Gmail ID, pmba@uhpd.ac.in. This is my official email ID. And then this is my personal email ID. So with the help of both the things, you can do the web conferencing. So if you're using personal Gmail ID, you can accommodate up to 45 members in your class. You can accommodate, you can accommodate up to 100 people in your meeting window. If it is G Suite based email ID, there you can accommodate up to 250 participants in your meeting window. So these are the provisions available with respect to normal Gmail ID based Gmeet and then your institution, I mean, G Suite based Gmail ID. So these are the differences with respect to using Google Meet as a web conferencing platform. And then you have one more platform. This is nothing but Jitsi. So even this is one of the wonderful open source platform. Even with the help of this jitsi.org, I mean, this is the site. Jitsi Meet also you can conduct the live sessions. So here up to 75 members can be accommodated in a meeting window. So you can accommodate up to 75 members here. Simply, I mean, to start the meeting, what you have to do is just click start a call. You go to jitsi-meet. You will get this window, and then you just press start a call. Then after that, what you do is you can have your own meeting window. For example, very long back, some 2 months back, I just used this particular meeting ID to start the meeting. Whenever I want to use the Jitsi platform, I'll use the same ID. I mean, unnecessarily, no need to create different IDs for yourself. For example, you are going to teach something called a chemistry subject for the whole semester. You create a meeting window with the help of this Murugan, I mean, on your name or maybe on your subject name, so that students will be able to easily able to remember everything. And with the help of the same ID, again and again, they can join in the meeting. Now, what I'm doing is I'm creating a meeting here with the help of this particular ID. No need to sign in, no need to have individual account. I mean, nothing is required. Simply you go to Jitsi and then type this. Then after that, you will be able to participate in the meeting. Now I'm just clicking join meeting. Now I'm there in this Jitsi Meet as well as in the Zoom. Basically, Zoom is used to demonstrate everything. Now I ask you to participate in this Jitsi. What I'm going to do is I'm going to share this Jitsi Meet window through the Zoom chat box. So now by clicking this link, you can also join in this meeting. This is the way how you have to share the link with your students. And then there's a way how participants can, or maybe your learners or students can participate in this meeting. Can somebody join with the help of this link? Same link only I have posted in multiple times. Yeah, already one of the person has joined here. So it says that fellow, yeah. So this is the way how you can join in the meeting, and then you can conduct the course. So this is one of the interesting platform, I mean, open source platform. Up to 75 members can be participated in this meeting. And if you see here, there are multiple options are available. So you can also record the meeting, that is possible. To record the meeting with the help of Jitsi, you need to have a Dropbox account. Dropbox is a cloud storage space. Again, that is free. You get 2 GB of storage space with the help of a free Dropbox account. So you have to have a sign in. I mean, you have to have the login credentials in terms of recording the meeting using Jitsi window. And then here you have a live streaming option. You can also.
Sir, excuse me, sir. Excuse me, Murugan, sir.
Yes, sir.
Sir, echo is going on, sir. Double time, your voice is coming in double time, sir.
Maybe because of Jitsi, I don't know. Now, sir. Now it's fine.
Yes, sir. In terms of recording like that, you are speaking, sir. Still, it is going on, sir.
I don't know, sir. From my side, I mean, everything is fine only.
Echo, yeah.
Are you using 2 devices, sir?
Yes, sir. YouTube live is going on, sir.
That's the reason, sir. That's the reason.
Oh,
no. What I'm saying is, in your window, if you would have activated both the YouTube live as well as Zoom, means you may be getting some 2 different voices.
Oh, fine, sir. So now I have to stop the live answer?
No need to stop anything, sir. No need to stop anything. If both the windows are active in your screen, means you may get 2 different voices. So better you mute the speaker of YouTube live so that you will hear only the Zoom voice, sir. Because in YouTube you will get some delay.
Yes, sir. Yes, sir. Got it, sir.
Fine, sir. Yeah.
Yes, sir.
Fine. Now, to do the YouTube live streaming also, simply you go to YouTube. Suppose if your principal wants to address your, entire college students for something on something. So what your management can do is they can use this free platform. If the meeting is for only 1 hour, means you can go for the live streaming with the help of this Jitsi, and you can copy paste the live streaming key from your YouTube channel over here. Sorry, over here, and then you'll I mean he or she can address the students with the help of this free account. No need to go for any of the commercial platform. So this is one of the another fantastic feature that is available in Jitsi. Now Jitsi is working on increasing the numbers, I mean number of participants who can attend the meeting in a single window. So they are working on that. So this all the ways how you can conduct your session. So here again, you have the screen sharing option similar to your Zoom platform or Cisco platform, and then raise hand. I mean, if somebody wants to talk to the speaker, means they can raise their hand. And then this is for chat. So here also you can do the chatting. So all those features are available here. So this is one of the nice and interesting and free platform. You can also make use of this particular so you can also make use of this particular platform. So once again, I'm saying that jitsi.org. So this is one of the free platform. So any, I mean, before attending this session, do you have any idea about this Jitsi? Can you say yes, or can you post yes in the chat window? No, I'm
Yes,
just trying to assess the awareness. Yeah. So you have some awareness, right, sir?
Yes,
No.
sir. We know about Jitsi, sir.
Oh, fine, sir. Fine, sir.
Without logging in, we can directly access Jitsi.
Yes, sir. Yes, sir. Okay, fine. Now, the next tool which I'm going to demonstrate is Gmeet. I hope, sir, in your institute, whether you have G Suite based ID, sir?
No, sir, it's independent, sir. Depends upon the staff faculty, sir.
Staff, okay.
Yes, sir. So
if
some of our staff members are using Gmeet and some of us are using Zoom, like that only, sir.
Okay, fine.
One of our colleagues is using Jitsi also.
Okay, fine, sir. Good, sir. Good. So if you have, I mean, you can request your authorities to make some MOU with Google. They will give you this G Suite feature. Basically, this, I mean, uohyd.ac.in. This is my university domain. And I'm using this particular Gmail ID, this particular official email in Gmail app. So basically, if you get a G Suite account, G Suite for education is completely free. Only thing is you need to have some MOU with the memorandum of understanding with Google. So they will give you, 10,000 users. Even for students also, you can create this. With the help of Google Classroom, you can, conduct the session. Even with the help of free Gmail ID also, you can manage everything. That is fine. But there are some limitations in the normal Gmail ID. But here you get 30 TB of, 30 GB of storage size in terms of using G Suite. So these are the other advantages over personal account. So if you want to create meeting ID here, simply you just go to Google Apps and then you click Meet, and then instantly if you want to click, instantly if you want to create a meeting, means just give you a meeting name for this, and then you can create it. That's it. So this is a way how you can create the meeting. Otherwise, what you can do is you can go to calendar. I hope everyone is familiar with Meet. So that's the reason I'm not spending much time here. Otherwise, what you can do is you can go to Google Calendar, and then in the Google Calendar also, you can click create, and then you go to more options. So here you can give the meeting title, and then you can select the timing of the meeting. Then here, if you click add Google Meet, so automatically it will create a meeting ID. So this meeting ID will be shared among the participants. So here it says that up to 250 participants, because it's a G Suite based ID. And then other features available here are, for example, for the whole semester, you are going to use a single meeting ID for conducting your live webinar sessions. For that, what you can do is, if you want to share some of the resources here, simply you keep everything in the Google Drive folder, and then you can paste the links here so that that will be there forever in their meeting window. So after some point of time, again, one more advantage of using Google Calendar based meeting invitation is your meeting ID will be stored in your Google Calendar. So whenever you want to go back and then if you want to check something, for example, here I just marked a meeting. I'm just clicking this. Currently this meeting is going on. So if I want to check the meeting ID, I can go to edit and then I'll be able to get the link here. So we are using the same link for 12 days. Basically, we are running some refresher course at HRTC. So we are, we are using this particular meeting ID, and then for the throughout the course, we are using the same meeting ID. So these are all the features available in Google Calendar in terms of using. Introduce one more feature. I don't know whether you have some idea about this particular feature in Gmeet. So for example, I'm just creating a Gmeet dummy meeting ID here. Sample meeting or Presidency College session. So now I'm trying to share this meeting link with the participants. So usually what is happening is we used to admit the participants. Every time we need to sit in front of our system and then we need to click admit. So this is the way how we are doing everything. Now what you can do is with the help of, there are some add-in programs are available. I don't know whether you have some awareness about all those add-in programs. Now I'll show you. Can somebody join this meeting window with the help of by clicking this meeting? Nothing will happen to you, don't worry. You just mute everything and then you just join here. There is an add-in program available called Meet Auto Admit. You can locate this Meet Auto Admit from Google Chrome extension and then you just add it here. After that you switch on. Whoever is going to join this meeting, they will be automatically admitted. For example, see, automatically admitted. I'm not pressing admit button here. One of the professor has joined here. I think Muthukumaran sir has joined. Yes, sir. So see, automatically I'm admitting everyone. So I'm not doing anything here. Automatically, it is getting admitted. So this is one of the nice add-in program recently developed and that is available in the Google Chrome extension. So you can make use of this particular extension. And now I'm going to show you, I think somebody's mic is on, kindly mute your mic. Even to mute all also, there is an add-in program available. I can click this meet mute. This will automatically mute everyone. So this is also another second add-in program available for Gmeet. And then the third add-in program is Meet Attendance. I hope you are having some idea about this Meet Attendance. So here in Meet Attendance, you have some of the things like add a new sheet and then existing sheet. So these are the features available. I hope you have some idea about this Meet add-ins also. Meet Attendance add-ons. So with the help of Meet add-ons, what you can do is simply you can take the attendance. Automatically attendance will be captured to those who are present in the meeting. For example, Balakrishnan J sir is going to use the same ID for the throughout the semester. In the very first class, you can ask your student to share their meeting ID details. For example, with respect to Dr. Balakrishnan J sir, his meeting window ID is Dr. Balakrishnan J, because this Dr. Balakrishnan J is associated with this Gmail ID or maybe any one of the email ID where he is trying to participate in this meeting. So you can make a note of everything and then you have a Excel file there. Automatically everything will be getting stored. But again, here the issue is, for example, Balakrishnan sir might have joined the meeting. During the session, he might have, muted himself, both, microphone as well as video camera. He might have left the place also. So we don't have any control over whether our audience or maybe students are listening to us or not. So for that, what you can do is, then and there, randomly, you can share Google Form based attendance link with the participants. For example, before start of this particular session, I think professor has shared some of the feedback link. So like that, you can share the attendance form, Google Form based attendance form among the participants or among the students, and don't disclose the timing, like when exactly you are going to share the attendance form. So this is, I mean, these are the features which you can use in terms of using Google Meet. And with respect to Google Meet also, you have one more interesting feature. Let me demonstrate that as well. Now I'm going to create one more meeting here. I'm going to create one more meeting here. For example, you are doing some combined courses, or maybe, for example, you are going to address some 500 participants. You're going to address 500 participants. Now what you can do is, you can have two different meeting IDs. You can have two different meeting IDs, and then you can, in one of the window, you can have, I request you to join in this link also. I'll demonstrate this straight away. Recently, I have posted a link here. Kindly join the meeting. Maybe one or two can join in this meeting. So now you are going to address 500 participants, and you have a Gmeet ID. And with the help of single Gmeet ID, you can accommodate only 250 participants. But you want to accommodate more than 250 participants. So what you can do is, as a presenter, you use both the meeting windows. For example, in one of the window, Balakrishnan sir and the Girish Gupta sir, they are there. And then in another window, yeah, Muthukumaran sir, and then Divya ma'am, and some more people also joining. So now as a presenter, what I can do is, I need to unmute both the meetings. I need to unmute both the meetings, and I have to share both the screens. I have to share both the screens. By doing this way, using one of the G Suite ID, I can accommodate up to 250 participants, including yourself. You can accommodate up to 240 participants. Using another meeting ID, as well as that is based on another G Suite ID, you can accommodate another 250 participants, so that you have close to what you call 500 participants can be accommodated, even with the help of this simple Gmeet ID itself. But again, there are some disadvantages using Gmeet. Issue is, for example, from this meeting window, Balakrishnan sir is trying to talk to me, and the people, those who are attending the meeting with the help of this meeting ID, they will not be able to hear anything what exactly Bala sir is conveying. But they'll be able to hear me, as well as they can see the screen. So this is the way how we are, accommodating more than 250 participants with the help of G Suite ID. So to run some of the webinars as well as classes, what I have done is, I requested my admin to create one more Gmail ID. So I have two official Gmail, G Suite based IDs now. And with the help of one of the ID, using this particular ID, I'm accommodating 250 participants. And then using this particular email ID, this was created exclusively for the workshop purpose. So with the help of this, I'm accommodating another 250 participants. And this is the way how I'm managing everything. Because in the recent past, during COVID time, I got close to 280 registrations for one of the program. It's a paid program only. So I don't know how to accommodate all those people. When I checked the Zoom and the Cisco and all, it's costly affair. I don't want to waste my money. Then luckily I got this, idea. Then I also checked before running the session. I also checked with the help of my scholars. It's perfectly working. Even I spoke to one of the technical guy from Google. They were saying absolutely fine to use two different IDs to run the same show. Then I have proposed this idea to one of the college in Coimbatore. So they were supposed to address some 1,000 participants in a single stretch. So without using any of the things, they just used 4 different meeting IDs, and then they have conducted the session. So this is the way how you can smartly think, and then you can manage everything with the help of some of the free features available in the web platform. So Gmeet is another wonderful platform. And then you have Cisco WebEx. Cisco WebEx is not free, but with the help of free account, you can address up to 100 participants for 50 minutes or 1 hour. That's the maximum duration. Of course, now you are using this Zoom platform. With the help of Zoom, you can accommodate up to 100 participants in a free account, and you can have up to 40 minutes as a meeting duration. So these are the limitations. But beyond the Zoom and Cisco WebEx also, there are so many platforms are available. I'm not going to explain everything here. And then for doing live streaming, I'm just suggesting this particular platform. The StreamYard platform is another, wonderful tool. Another wonderful tool. So with the help of this StreamYard platform, what you can do is you can create a live streaming with the help of free account. You get 6 members. At a time, 6 members can be participated in this meeting window. For example, your principal and then Muthukumaran sir, 2 of them can join using this StreamYard so that I can have a live interaction with them. And I can also create a YouTube live session with the help of this StreamYard. Only thing is I have to synchronize my YouTube Gmail account with the StreamYard. Then after that, what whatever I'm speaking here, whatever I'm sharing here, everything will be telecasted through YouTube. I think in the free account, the maximum duration of using the StreamYard is 30 hours. In a month, you can have up to 30 hours of live streaming. For live streaming and all, I don't think so. We are going to run some sessions beyond 30 hours. So with the help of free account also, you can make use of this particular StreamYard. So this is another, even if you want to pay something, it's not really costly. It's much, much, much cheaper than Zoom and then other platform. For running webinars, I strongly recommend this particular platform. Either you can use it as a free platform or paid platform. It's up to you. For running closed group discussion, yes, of course, Zoom and other platforms are wonderful platforms. So this is another platform. And then for live streaming, again, you can use OBS Studio. So now what I'll do is I'll show you how to record your own videos. I hope you know how to record the videos using Gmeet, right? Can somebody post something on the chat window? I just want to check whether you have some idea about this. If we click the link and the process will go, but suddenly shows failed to join meeting, why, sir? A reason is maybe internet connectivity issue from your side or maybe the host side. I don't think so. I have not faced this particular issue so far. A reason could be you might have received the link through Google Calendar and you might be using some other Gmail ID to join the meeting. Even that can be the reason, but mostly internet is the major cause. Durga Devi ma'am, this is the answer for your question. So do you have any idea and awareness about how to record the meeting using Gmeet?
Sir, we have no idea, sir, recording video.
Sorry, sir. Sorry.
Sir, we have no idea about recording the video in Gmeet, sir.
Okay, fine. I'll show you. If you are using G Suite based Gmail ID, you have this feature. So I'm creating a dummy meeting here. And then what you can do is, let me mute my camera in Zoom so that I can use the camera here. So now I'm going to create a 5 minutes or 10 minutes video lecture for my students. Now what I can do is I can create a dummy meeting, something similar to this. And then go here. First you share your screen. First you share your screen. First share your screen. Then after sharing the screen, what you do is you open your PPT. For example, let me open a PPT. You open your PPT. Then after that, what you do is you go to Google Meet window, and then here you have this option called record meeting. Whether you are recording live session or whether you are going to record the presentation, it can be anything. Whatever you are showing it on your screen, everything will be captured here. Now I'll show you how this recording is happening. So I'm just pressing record meeting, accept. So it's a dummy meeting only which I have created. Now what I'm going to do is I'm going to record my screen. Whatever maybe the recording is on. And now I can start something like this. Dear learners, today I'm going to don't use today and good morning, good afternoon and all. Dear learners, in this module we are going to discuss about understanding theoretical contribution and try to understand why our papers are getting rejected from top tier journals. So these are all the reasons. So for sample recording purpose, now let us assume that I have made this presentation. Now I'll click stop recording. Stop recording. This particular recorded version will be saved in your Google Drive folder. This recorded version will be saved in your Google Drive folder. It may take another 2 to 3 minutes time to save the recorded version. Please wait for some time. After that, you will be able to get some, folder called meeting recordings here. So if you go inside into the meeting recordings, you will be able to see the recorded content with respect to whatever maybe the meetings which you have conducted in the past. So for example, I'm just opening a recorded version of the meeting, or maybe some sample presentation. This is how your recorded version will look like. So one side you will get the face, another side you will have only the screen. So that's the way how the Gmeet can record your lecture sessions. Then after that, you can upload this video into YouTube, or maybe you can keep it in the drive itself. You share this recorded version with your students. They can watch it on their screen. So this is the way how you can make use of this particular Gmeet for recording. The same thing is available. For example, here is a sample recorded item. I'm just playing this video. Taking some time to play. Just give me a minute time. Some error. I don't know the reason. Yeah, I'm waiting to receive one more recorded content, because just now we have activated the recording, right? So I'll be able to get. So this, we did a doctoral committee meeting and we have recorded everything. So here is the, video of that particular recorded content. So this is a way how you can record, and then you can share the recorded version with your students. Even if you are doing live demo session, live web session with your students, part of your core teaching, again that can be recorded, and then you maybe after the class also you can share the link with your students. Even they can also watch it, suppose if they would have missed that particular live webinar session. This is another fantastic tool. Give me some more time. I'll be able to get that newly recorded content, because I'll be getting a notification in my updates folder for the newly recorded content. So give me some time. I'll be able to do that. Now, this is what you can do with the help of Gmeet. Similarly, if you want to conduct live, streamings, live streamings with the help of YouTube, what you can do is you can use OBS software. There is a software called OBS. So with the help of OBS software, what you can do is you can connect this particular meeting window. And then you have to copy paste the YouTube live streaming key over OBS Studio. Then this will be synchronized or maybe integrated. Then after that, you can start speaking in front of this meeting window. Everything will be telecasted on live basis through your YouTube channel. So this is also another fantastic feature. To demonstrate something about OBS, I need some more time. Let me see the questions. If we click the link, and the process will go, but suddenly shows failed. Yeah, this we have discussed. Will there? Yes, sir. Will there be a clash over one application using the camera microphone when we use it for different web platforms, as in multiple web browser windows? In some of the cases, in Zoom, Cisco WebEx, I'm getting some issues with respect to using cameras. For example, now I'm using the camera in Google Meet. I have muted my camera in Zoom. When I click unmute camera, it is not accepting. But when I use two different Gmeet windows in the same browser, I'm not getting any issues with respect to using the cameras in both the meeting windows. I'll show you right away. See, now both the meeting windows are open. In both the places, you can see my face, you can see my mic. This I have noticed when I tried to do simultaneous live streaming using Facebook as well as YouTube Live. So when I use the camera in OBS, I could not able to use the camera in Facebook. So yes, in some of the cases, yes, this issue is coming. But with respect to Jitsi and Google Meet, yes, I'm not getting any issues. For example, now I'm going to create a meeting in Jitsi as well. You just see whether my face is visible on the screen or not. Even you can use same browser or you can use two different browser. It's up to you. But whenever you are hosting something with the help of two different meeting IDs, my suggestion would be you try to use two different browsers for accepting the participants. If both the meeting IDs are available in the same browser, means you will get some issues in terms of logging into your Gmail ID. So that's the issue. See here also your face is visible. So now, for example, you're going to address 300 participants and you don't have money to buy anything. Use Jitsi 75 members or use three different Gmail ID based Gmeet 100 plus 100 plus 100 300. Easily you will be able to cover everything. So this is a way how you can make use of some of the free platforms for your online teaching. This is one of the thing which I thought of showing it to you. Now I'll show you the recorded content. I got the notification in my email. So this is what now I have recorded. Now I'll try to play this video and then you will be able to see something. For all those demonstration, already have uploaded a video in my YouTube channel. If you want to get more idea about Gmeet, you please visit my YouTube channel. There are some videos are available. So this is the short video which I have created just to demonstrate how you can record your video lectures using Gmeet. Even with the help of Zoom also, you can record the video lectures using free account. Up to 40 minutes content can be created with the help of free Zoom account. So no need to depend on any of the commercial or paid softwares for recording your content. Simply you can make use of some of the free softwares or open source platform that is available to us through from Google or maybe from any of the other sources. So these are all the ways how you can make use of everything in terms of running your online classes. And in terms of sharing the resources, if you don't have much expertise with using Moodle platform, Moodle as a LMS platform, at least you start with the Google Classroom. So with the help of Google Classroom, you get 15 GB of storage space. So you can share any kind of materials with the audience. So probably you can also start with the Google Classroom in terms of sharing the resources with your students. That is one possibility. Second possibility is even you can also use Moodle. There are some sites like Moodle Cloud, Genomio site and so on. So with the help of those sites also you can make use of Moodle. It's not playing from the drive. Let me download this file and then I'll open it with the help of the local app, VLC app. Hopefully you will be able to see the recorded version. Yeah, I'm trying to download this video. Small video only, it won't take much time. Now I'm playing the video. See, this is how your recorded content will look like. So what I'm trying to convey here is something is better than nothing. So we can make use of this free softwares for your own class lecture recording purpose. So that is what I'm trying to convey here. The problem is only in, okay, I think there are some follow-up questions. Gmeet personal ID cannot this recording. Yes, Gmeet personal ID is not having this recording button. That's why I'm saying you use personal Zoom account or Jitsi account to record your content, Divya ma'am. That is what I'm trying to say here. Gmeet personal ID cannot, yes, it won't do the recording. Is it possible to use all these features in mobile phone? Yes. In mobile also you have this Gmeet app. Basically you have to download the Gmeet app, and then with the help of the Gmeet app you share your screen. You open your you can open your what you call the Gmeet account, and then after that what you can do is you just share your screen and then you try to open your PPT, and then with the help of your smartphone also you can do everything. That is possible. If the G Suite ID is associated with one of your Gmeet ID is associated with G Suite, means simply you try to start the recording process, and then that will be recorded and then that will be stored in your drive folder. After that you can access everything with the help of desktop or maybe with the help of your mobile. That is possible. Yeah. Any other follow-up questions?
Any other questions? So whenever you want to record your content for video lecture production process, you sit in a place where you don't get much noise. You sit in a place where you don't get much disturbances. Better, I mean, idea is you sit in your bedroom because there you have mattresses and other things. So you don't get much noise actually. So this is the way how you can make use of some of the free platforms for conducting the session. Is it possible to use all these features in mobile phone, but I was unable to take attendance Google Meet? Yeah, in mobile, yes, it won't work. Yes, for that again, you have to, I don't know whether Meet attendance app is available in mobile version. I don't think so. So for that, you have to use this desktop version. What are the basic requirements for a PPT slide screen share based class with short videos over mobile? AIZ recorder can be used for recording your screen with the help of mobile. Also, you can do that. That is possible. Second possibility is what are the basic requiremements for a PPT or slide screen share based class with short videos over mobile? To conduct live session, Purnam sir, or to record the content? Live. Yeah, you can share whatever you are going to share the PPT. You keep your PPT in Google Drive, open it through Google Slide, and then you just even no need to have Microsoft PowerPoint app in your mobile. Just open it through Google Slides, because Google Slide is a cloud-based one. This Google Slide is a cloud-based one, and then you just open it, and then you share your screen with the help of Meet, and then you try to address your participants. So in our I mean state, I don't think so. None of the classes are going to have more than 80 people or 90 people. If that is the case, even using this free Meet ID is more than sufficient for our regular teaching. We are using multiple apps. What about their safety? My personal opinion is nothing is secured in this era. This is what my opinion. We say that this email ID is highly secured and protected by Google, but I don't think so. I don't think so. Sir, please demonstrate how to take attendance in Zoom and Gmeet. So to take attendance in Gmeet, what we can do is, now I'll log into a live session that is going on. Just give me a minute time. The way how we are taking the attendance, I'll show you. Let me mute everything here. So this is one of the live session that is going on here. We have added a Meet attendance here. See, there is a Meet attendance add-in program is available. So this is what Meet attendance options. If you further click, you will get a right click, add a new sheet, create a new sheet, and then switch on or switch off. When I click this switch on, I need to associate this particular meeting ID with the original meeting window. Then after that, if you go here you have this option, right? Yeah, here you have this option, right? If you switch on this, if this meeting ID is associated with the original Gmeet account, means I'll be able to switch on this. After turning on this two buttons, I'll be able to automatically capture all of the people, those who are attending this particular meeting. If you see the Excel file which I have created here, the meeting ID is, this is the meeting ID, I mean the current meeting ID, and all those attendance, whatever may be the attendance which we have captured day wise, everything is available here. This is the way how we are capturing the Meet attendance. So for that, what you need to do is you need to visit Google Chrome extension, simply type Meet attendance for Google Chrome, and then you will get this extension. Initially, if this particular add-on is not included in your video, means, sorry, not included in your Google Chrome, means you will say add into Chrome. I mean, you will get a message called add into Chrome. Now already have added, so that's the reason it says remove from Chrome. So this is what Meet attendance. So very simple procedure only. So with the help of that, you can take the attendance. But here the issue is the actual student name is Murugan P. But in my Gmail ID, suppose if I would have given P Murugan or maybe only Murugan, means it will capture only Murugan, not Murugan P and whatever that is there in your record, that may not be matching with their Gmail ID name or maybe any of the other email ID's name. So that's the limitation of using Gmeet attendance. Yeah. Yeah. Any other questions? Sir, please demonstrate how to take attendance in Zoom and Gmeet. Yeah, in Zoom it's very simple. So you go to this more option, and then here I think you need to sign into the Zoom account in the web platform. There you have the provision to monitor the people, as well as you can extract the names, as well as even you can save the entire chat. I'm not the admin of this particular Zoom ID, so they'll be able to do that. Otherwise, I'll open my Zoom account, then I'll show you. Yeah, let me see. Are there any other questions? How to set long time in Zoom? For that, you need to buy the Zoom account, Professor Ravi. Professor, you have to buy the Zoom license. In free account, you get 40 minutes of meeting duration. I don't know which ID I have used for this. Let me try to locate it.
Sir,
No,
shall I give my ID and password of Zoom, sir?
No, sir. In the public window, no need to give, sir. No problem. Not an issue, sir. Maybe at the end also, I can show you. And let me take other questions. No, I don't know the password which I have used for my personal Zoom account. I'm not having official Zoom ID, but I have created just for this kind of demonstration purpose. I just created a personal Zoom account. So I don't know the password. I need to check. Let me go to the associated ID and then I'll try to check it. These are all unnecessary things. Sir, up to what time I can go, sir?
Sir, it's your choice only, sir. You are the last
but actually the session ends.
The next session will
right?
start at 2 o'clock, sir. So we have to give at least half an hour, 1 hour break.
Fine, sir, fine. Yeah, and one more simple information to understand everything is, you go to YouTube, and then whatever may be the questions you are having, you just type it in YouTube. For example, I'm just typing meet attendance. See how to take attendance in Google Meet. A lot of videos are coming. Similarly, if you go to my YouTube channel, here I have created a lot of different playlists. One of the playlists is related to Google Tools. So here I have given some explanation to understand how to use Google Meet and so on. I'll show you that just a minute. Playlist. So here I have the video on accommodating more than 250 participants in Google Meet. So it has got 6,000 views. So which means that people are watching this and then appreciating. Even I got 68 likes and 10 dislikes. So what I'm trying to say is, like this, there are so many videos are available. So you try to make use of all those videos to learn any of the softwares. That is my kind suggestion. I think I can stop here because the scheduled duration is only 45 minutes. I hope I have completed, attained my both of the objectives which I have mentioned in the early part of the class. So if there are any doubts, you can reach me through this address. This is my personal website. So this is my email ID. So you can reach me with the help of this particular site. And in my site, I have organized some of the videos like Google Tools videos, research methods. I don't know. I think most of them are from chemistry and other science background. So these videos may not be useful to you, but make use of this open educational resources videos. So it may be useful to you. I thought of covering this particular part at least for next 10 minutes, but already it's 12:10. So I'm just skipping this. But I'm sharing the links. You please watch these videos. You will get really good clarity about how to use open educational resources for your online teaching. Yeah, everything is my own videos only. Yeah, anything else? Yeah, any other questions? Yeah, I think somebody has raised their hand. Yeah, you can come to the live.
Participants, you can unmute yourself and you can ask the questions.
2 new messages. No, only they are saying thank you only.
Okay.
That's okay. Yeah. Thank you, sir. Thanks for organizing this seminar. I mean, you're doing, in
Thank
fact,
you very much,
wonderful
sir.
job, sir.
Yes, sir. Thank you, sir. Thank you, sir.
Thank
Because
you.
you have no time to give you a lecture. So you are so busy. We know about you, sir. Because
Okay.
you are giving online teaching and online lecture throughout the nation. We know about you. Only because you are also from our native, no, sir. You
Yes,
are
sir.
also
Tamil
from
Nadu,
Tamil
sir.
Nadu.
Tamil Nadu, sir.
Yes, sir. உங்களை எல்லாருக்கும் இன்ட்ரோடியூஸ் பண்ணி வைக்கணுங்கிறதா எங்களுக்கு நோக்கம் சார். இவ்வளவு பிரைட் ஃபியூச்சரோட நீங்க இருக்கிறது எங்களுக்கு எல்லாம் பெருமையா இருக்கு சார். தேங்க்யூ வெரி மச் சார்.
Thank you, sir.
Thank you, sir, for sharing your valuable time and for the lively and useful presentation, especially for teachers at this time of COVID-19. We appreciate your expertise, enthusiasm, and pragmatic approach. Thank you for sharing your valuable
Thank you, ma'am. Thank you.
Thank you so much.
Thank you.
Thank you, sir.
Thanks, sir. Thanks, sir. Yeah, bye-bye. Bye, sir.
Dear participants, thank you for joining us for the morning session. Let's see you again at 1:50 p.m. for the post-lunch session. Thank you.
GM sir.
சார் ஜிஎம் சார் சொல்லுங்க சார்.
சார் தேங்க்யூ சார்.
சார் தேங்க்யூ சார். தேங்க்யூ சார். மதியம் 2 o'clock மீட் பண்ணுவாங்க சார்.
2 o'clock பார்க்கலாம் சார்.
எஸ் சார். எஸ் சார். தேங்க்யூ சார். உங்க போட்டோவை காமிக்க மாட்டேங்கிறீங்களே. சார் தேங்க்யூ சார்.
ஓகே சார்.
சார் சுந்தர சார் தேங்க்யூ சார்.
தேங்க்யூ சார். தேங்க்யூ சார். பாப்போங்க சார்.
எஸ் சார். விஜய் சார் இருக்காங்களா? சார் விஜய் சார் தேங்க்யூ சார். தேங்க்யூ சார். எஸ் சார். மதியம் அவுட் ஆஃப் தேங்க்ஸ் இருக்கேங்க சார்.
பாப்போங்க சார்.
நான் ஃபோன் பண்றேங்க சார். விஜய் சார் நான் ஃபோன் பண்றேங்க சார்.
ஓகேங்க சார். ஓகேங்க சார். சீ சார். பாப்போங்க சார்.
மேடம் அச்சோடி மேடம்.
தேங்க்யூ சார்.
மேடம் தேங்க்யூ மேடம். மதியம் 2 o'clock நம்ம 1:50 ஆன் பண்ணிடலாங்க மேடம். 2 o'clock ஸ்டார்ட் பண்ணிடுவாங்க மேடம். மேடம் நான் கால் பண்றேங்க மேடம். தேங்க்யூ மேடம். தேங்க்யூ மேடம். மேடம் டபிள்யூஎஸ் மேடம். மேடம் டபிள்யூஎஸ் மேடம் இருக்கீங்களா? $150 மேம். 150 மேடம் 150க்கு ஸ்டார்ட் பண்ணிடலாம்.
ஓகே.
தேங்க்யூ. Sir, good morning, sir. Good morning, madam. Good morning. சார் சுந்தர சார் கேக்குதுங்களா சார்? ஆடிபிளா இருக்குங்களா சார்?
கேக்குதுங்க சார்.
Thank you.
Good afternoon, sir.
Good afternoon, sir. Good afternoon, sir. சார் ப்ரொஃபசர் நடராஜன் சார் வந்துட்டாங்களான்னு பார்த்துடலாங்க சார். Sir, good afternoon, sir.
Sir, good afternoon, sir.
Sir, good afternoon, sir. Sir, Professor Narayan, sir.
Good afternoon, sir. Sir, unmute பண்ணிடுங்க சார்.
Sir, unmute பண்ணுங்க சார்.
Okay, sir. Yeah.
Thank you, sir.
Now okay.
Sir, now it is okay, sir. Madam, HOD madam.
Yes, sir.
Ma'am, sir has come, ma'am. Narayan sir வந்துட்டாங்க, madam.
How are you, sir?
வீடியோ ஆன் பண்ணனுங்க மேடம். வீடியோ ஆன் பண்ணாம இருக்கீங்க மேடம் உங்களுக்கு. Yes, ma'am.
How are you, sir?
Yeah, thank you. Fine.
HOD madam, sir.
Nice to meet you.
Sir?
Yes.
Thank you so much, sir, for your acceptance.
Yeah, thank you. I should say thank you to you.
Deliver the lecture, sir, in spite of your issues.
Thank you. I should say thank you to you.
Thank you, ma'am.
So, do you hear any background noise from my end?
Yes, sir. We can. Sir, this is our senior professor, Dr. Jaishankar, sir.
No, sir. Nice to meet you. Yes.
Welcome, Professor.
Okay, thank you. So, do you hear any background noise from my end? Or
Yes, sir. Yes, sir. Some noise is coming. We are searching where it is coming.
I will try to switch off the fans.
It's really screeching, sir.
Yeah, now also do you hear?
Yes, sir. Now there is no noise.
Yeah, I think that I'm sitting in the lab. The background.
Background. Another 2 more minutes are there. We can start at 2 o'clock.
Sure. Yeah, definitely. Yes.
Madam, HOD madam, start பண்ணிடலாமா madam? HOD madam?
Yes, sir, you can start, sir.
Yes, ma'am. Thank you, ma'am. Ma'am, WS ma'am, please. Sir, this is our staff member, sir, my colleague, sir. This is Dr. W. Shanti, sir.
Nice to meet you.
She is the master of ceremony.
Good noon and welcome back to the post-lunch session. A few announcements to the participants. E-certificate link will be sent to your register mail ID in a couple of days. An attendance link will be sent in the posted in the chat box before the end of the session. Thank you. Well, let's move on to the presentation. The first presentation of the session is on the topic Self-Assembly of Metal Organic Cages by Dr. R. Nadarajan, Principal Scientist, Organic and Medicinal Chemistry, CSIR, Indian Institute of Medical Biology, Kolkata. I'd like to share a few words about Dr. R. Nadarajan. After his post-graduation in Anna University, he received his doctoral degree from IIT Kanpur. He was a postdoctoral fellow in 3 universities: Pohang University of Science and Technology, Korea, University of Würzburg, Germany, and University of Bristol, United Kingdom. His area of research activities includes synthesis of supramolecular receptors, molecular recognition, and crystal engineering. He is having a sizable number of publications in national and international journals. We are so fortunate to have him with us today, and I now leave the floor to Dr. R. Nadarajan for the presentation.
Thank you for the nice and lavish introduction. So let's start now. So please let me know the screen share is available to you.
Yes, sir. Yes, sir.
Yeah. Okay.
Yeah.
So now I can slowly move on. Right?
Yes, sir. Please, sir.
Okay. Yeah. First of all, thanks for the nice opportunity to interact with you. I wish I could speak with you in person, but unfortunate situations. Nevertheless, still I thank you very much for this opportunity. Okay. So I briefly talk about a small field of research, something called self-assembly of metal organic cages. Okay. So I think in your curriculum you have a paper on something like supramolecular chemistry, if I'm correct, hopefully.
Sir.
Yeah. Okay. So then I don't have to give big introduction about that field, but still I briefly talk about a couple of fields. Okay. So one has to wonder why we should learn about supramolecular chemistry, self-assembly, non-covalent interaction, molecule recognition, and post-twist complexes. What is the use of it? So why is this some academic curiosity? People publish on research papers, or is there any practical applications out of that field? Okay. So definitely there are some practical utilities out of these research activities. So before I move inside, so this supramolecular chemistry is more about chemistry beyond the molecule. That's what people claim. So it's a chemistry beyond the molecule, whereas molecular chemistry is about the covalent bond formation, whereas the supramolecular chemistry is about how molecules interact with each other to form some stable organized assemblies. Okay, so they interact with multiple of non-covalent interaction. They may be due to like hydrogen bonding, metal ligand coordination, halogen bonding, van der Waals interactions, and dipole-dipole interactions, and various non-covalent interactions play around with molecule each other to form a organized assemblies. The self-assembly is about the spontaneous association of molecules under equilibrium conditions to form stable and structurally well-defined aggregates joined by non-covalent bonds. So the self-assembled product may be of different shape, like it may be a crystal. Crystal is a perfect example for the self-assembly, or some kind of vesicle or bilayer. And the self-assembly may exist only in solution state, or in gas phase only, or in solid state. In different level we observe the self-assembly. Okay. So the field is, these are the 3 people, they are kind of forefathers of this field. So they got the Nobel Prize in 1987. So 2 of them are no more alive, and 1 person, the middle one, John Maryland, is still very active in his research in the recent years. And these are the other 3 people who got the Nobel Prize a couple of years back for their work on the molecular machines based upon the principles of the supramolecular chemistry. So there are different kind of self-assembled materials. So one among them is like making a post-twist complex between a receptor, synthetic receptor, and guest molecules. So calixarin is one of the very old receptor known to the mankind. So even it is more than 100-150 years back was first isolated. So the applications of calixarin is well documented, we are all using in everyday life. So it is there in our shampoos, soaps, and deodorant spray. So the thing is, like, we have a fragrant molecule, so they are readily going to gas phase, but we trap them as a non-covalent complex, and we slowly release them upon spraying over there. So like a body spray, which is long-lasting body spray, and shampoo, which is giving smell for long duration, they are all mostly due to the cyclodextrin and the fragrant molecule host-host complex formation. And this another example is very beautiful example from developed by Professor Profana D. Silva. So what they have done is, so they developed a system called fluorescent sensor for the cations. So you might have studied crown ether, it binds potassium cation sort of thing. Okay, I guess. So what they developed is how we can take a output of binding event into fluorescent signal sort of thing. So there is a, what they developed is like a fluorophore. So this particular fragment, this is the fluorophore, naphthalene monoimide, and you have a binding moiety over here, crown ether, and it is binding with metal ion over here. And by default, in the absence of metal ions, the molecules are not fluorescent because there is a phenomenon called photo-induced electron transfer. So you excite the molecule, but there is a nearby amine moiety over there, and so there is intramolecular electron transfer happen between the excited state. So the molecule is not fluorescent. Whereas once you put the cation, once the cation comes and binds, then lone pair electrons of this nitrogen moieties are no longer available. So the molecule becomes fluorescent. So depending upon the different binding moiety, so one can selectively make a sensor for potassium ion or sodium ion and calcium ion. So this is academic research. What they did, they incorporated this fluorescent binding moiety into a polymer backbone and put it in a stripe kind of stuff over here. So where the small circle, what we see here, so this is one for selective receptor, one for sodium ion, one for potassium ion, and one for calcium ion. And this is like a small cassette, and they put it in this instrument. And when someone made accident, and when there is a huge loss of blood, and before the patient was taken into hospital, so people want to know what is the concentration of ions like sodium ion, potassium ion, or chloride ion, these kind of ions in the blood, and accordingly one has to adjust the concentration from the transfusion blood molecule. So from the simple academic research like the host-guest complexation and the further fluorescent sensor sort of thing, and people developed some sort of sensing device, and with which people made huge amount of money. So not only money, it is serving the humankind. So that is two important things. Okay. So now there is another some evolving research, something like that. So this particular group, Professor Anthony Davis, they developed a cage kind of receptor. What you see here, this is purely organic cage molecule. So the cage means, when we say cage, a macrocycle is like a simple cyclic molecule, like a bangle-shaped molecule. When you have a macro bicycle, what we call them as a cage, like so that they can trap something inside the cavity area. So these people developed this bis-urea kind of cage kind of receptor, and this binds a sugar molecule. So then they spin off a company and started a spin-off company and developed a fluorescent receptor kind of molecule for the glucose binding assay. Then over the time, they sold this company to some big biopharma industry for some like $800 million sort of money. So it's from a simple academic curiosity. So one could go on with come up with a spin-off option and develop a system and sell it off to some big pharma, and not so that we can get money out of the system and serve the human being also. Okay. So these are some three simple examples which come to my mind when we talk about why one should bother about supramolecular chemistry and what is the purpose of making receptors and doing host-guest complexation sort of thing. Okay, so now I slowly move into the topic of the day. So what is the title? What we talk about? Self-assembled metal organic cages. So as I say, the cage is something like a molecule. You have a macro bicyclic system. It can be assembled through either purely hydrogen bonding. So the resarcinarine, so what we see on the left corner, this resarcinarine, it is a beautiful example. So if you simply take the resarcinarine and put it in methanol and water, it forms a octagonal shaped molecule like this. But it has a challenge. The hydrogen bondings are not strong enough, so they are not stable enough for a lot of practical applications. So one can have a cage due to non-covalent interaction like hydrogen bonding, but it is not going to be that stable. One can think of having a purely covalent cage molecule, but again, making the molecule is highly challenging. Although they demonstrated with so much of commercial success, the synthesis is not going to be that easy. Then there is another example, another option is like coordination driven self-assembly. You have a ligand and bidentate or tridentate ligand with certain symmetry, and you mix them with a specific metal ion, and they undergo coordination in a reversible manner, not very strong, not very weak, but they are reversible and thermodynamically stable, and we end up getting a discrete cage kind of molecule. So this is the one which I'm going to talk about today. So something called what we call metal organic cages. Okay. So in principle, what happened if we take a bidentate ligand, so it may be either linear or a little bit bent, and mix it with metal ion of appropriate chemistry behind it, and we have two options. One, they can end up giving a polymeric product, or they can give a discrete assemblies. Okay, so the choice is based upon what kind of metal ions we are taking and what kind of the ligands we are taking. Okay, so this is already well established. So compared to this metal organic cages, this metal organic framework, this particular field is so exhaustive nowadays and so well matured, and so many people are working around the world, and it shows a lot of practical applications like gas storage, gas separation, heterogeneous catalysis, even water harvesting from the atmosphere sort of thing. On the other hand, the metal organic cages is like a small baby kind of field. So compared with metal organic framework. So here the logic is you try to have a ligand, like a functionalize the linear ligand or a little bit bent ligand, ideally the bent ligand, not a linear one, bent ligand, and put some pyridyl group or carboxylic acid group and take the appropriate metal ion so that they form coordination driven self-assembly to form a discrete cage kind of molecules, and they exist in solution. Whereas the metal organic framework are crystalline solid and they are polymeric, whereas they are not soluble in solution. Whereas metal organic cages are, they exist in solution. So we can record NMR, we can record mass spectral characterization, we can get a definite molecular weight. Okay, and this molecule with a cavity inside, so they mimic something like a enzyme binding pocket of the enzyme. So people think of, okay, can we try to do some chemistry which what biomimetic by mimicking the biology, like enzymes do a lot of reactions with extraordinary rate acceleration, whereas whatever the characteristic human made so far, so we couldn't reach that kind of catalytic activity in terms of turnover number, how fast you can get, how selectively we can get the product. So still people are trying to mimic what enzyme is doing for the catalysis, and whether we can mimic them by making some enzyme kind of molecule, but not such a bulky big size molecule, but in a very small and specific cavity with specific functional groups inside the thing. So this metal ligand coordination driven self-assembly is the ideal opportunity. It gives ideal opportunity to form this kind of enzyme molecules. So one can visualize to do some reactions inside the cavity. One can stabilize some very reactive intermediates, like some of the transition metal species, are not even some neutral species which are very reactive, very transient. So we can stabilize them even in a competitive solvent. So these are the idea behind people making metal organic cages. So now I briefly talk about some of the very popular metal organic cages known in the literature. Then later I talk about the work, what we have done in the recent past on this field. Okay. So this particular molecule, something what we call Fujita cages, because they are so popular and people put the name of the scientist behind this cage molecule. Okay. So what they have done, so they have taken a simple C3 symmetric tripyridine molecule. Okay. Then they took a palladium. So they end up the palladium with ethylene diamine. Okay. Then other side you have the nitrate counteranions. So what they call it, ethylene diamine palladium nitrate. So this gives a specific binding angle. So two sides are protected, only other two sides are available for the germ coordination. So what they did, simple reaction. You take the ligand and take the metal ion and mix it, and if needed, little bit polymer. Then at the end, what we get is a selective single discrete product. So no polymeric product, no other isomer, you end up seeing a discrete product. So what they got is like a 6 metal ions and 4 ligands. So the ligand, you see the triangle over here, the green color one. So they mimic the triangle and mimics the ligand. So you can visualize it's like an octahedra kind of cage. On all the 6 corners, you have the metal ion, and the top 2 fins are open with the ligand, and the other two fins are empty. So it's like an octahedron, but 2 fins are empty and 2 fins are open. 2 fins are closed. Okay. So this one's very simple system, and they demonstrated with so much of chemistry with this host molecule. So this is like a host molecule. So you have a beautiful cavity inside, and this is water soluble because we have a nitrate counteranion. So they demonstrated so many different examples, but I just briefly talk about a couple of them. So one interesting one is about the Diels order reaction with unusual reactivity, unusual regioselectivity. Okay, so what they took this anthracene and melee moiety. So normally when we try to do the Diels order reaction with this thing, the 9-10 position of the anthracene is the one which is undergoing the Diels order reaction. But what they did, they took the diene and dienophile and put it in this cage moiety, and they did the reaction for certain duration. What they observe is they got some unusual regioselectivity. Instead of 9-10, you end up seeing 1-2 cycloaddition sort of thing, not 1-1-4 sort of thing. For comparison, they made another cage which is like a half bubble, and unlike the other one octagon, this is half bubble. The only difference is the pyridine positions are different. So you end up having this kind of half bubble. This also performs the catalysis or the same Diels order reaction, the usual stereochemistry. So that they could demonstrate that, okay, you take a different cage molecule and you can do the Diels order reaction with an enzyme like catalysis, and you get some unusual stereochemistry. If you try to get this particular product, what we see on the left hand side, we could never get without this kind of host molecule in our hand. Okay. So then what they went further, so instead of a simple C3 symmetric ligand, if we take a simple linear, little bit bent ligand with certain bite angle and with different spacers, in this case, what we see here, 1A, 1B, and 1C, like the benzene spacer and furan spacer and little bit longer linkages, people end up getting 12 palladium ion and 24 ligand made up of a cage moiety over here. As you can see, the reaction is very simple. You take the ligand and you take the metal and you mix them and stir it for some, leave it at a NMR tube at certain duration, and you end up seeing the beautiful NMR spectra and beautiful mass spectra. Then even you do the X-ray crystallography to confirm the molecular structure. So what they observe is M12L24 kind of giant size molecule. Then they went further couple of steps ahead and they made another ligand in which they put the thiophene moiety inside, and the other side they put the selenium moiety. So that change of small atoms like sulfur to selenium and gives a ligand with a different bent angle. So the left one is having around 140, whereas the right one is having 152 angle, and it upon self-assembly with the palladium. So in this case, it is palladium nitrate, not ethylene diamine. So they are simple palladium nitrate. So all the 4 positions of the palladium are coordinated by the same pyridyl ligand. And people end up getting the M24 and L48, on the other hand, M48 and L96. So the right-hand side is the one, so far the obtained very giant size discrete cage molecule so far known in the literature. Made couple of years back only. Okay. So now I move into some other kind of cage molecule. So this particular one is developed by Professor Jonathan Nitschke at Cambridge University. So what he did, he took this diamine molecule and formed the imine bond formation with pyridine to carboxaldehyde. So then in principle what they did, they took the biamine and dianiline moiety and pyridine to carboxaldehyde along with the iron 2 sulfate. Okay, so the imine bond formation also happens in situ, and further metal coordination also happens to form a discrete tetrahedral cage molecule. So here also, since the sulfonic acid moieties are there and the basic linker, and it is water soluble molecule. So you have a simple one-step reaction and you end up getting a beautiful tetrahedral cage. So what they demonstrated, so this is a water soluble cage, and when they put the phosphorus, white phosphorus, so that is highly flammable molecule, highly flammable, and the cage molecule is stabilizing the phosphorus even in the aqueous solution. Okay, so this is some sort of a beautiful example of having a supramolecular receptor and which stabilize highly reactive transient, highly reactive species even in competitive solvent like water molecule. Okay, so now I move into another beautiful system developed by someone called Professor Michito Yoshizawa. And what they took, so they took a simple bispyridyl ligand. So they have a pyridine moiety over here, and you have a spacer here, and you have the 2 anthracene fane. So you have a banana shaped ligand. So the ligand is more like a banana shape, and you have a pyridine on the 2 terminal, and these R groups are introducing solubility. So you put some alkane chain and you let it undergo self-assembly with palladium ion, and you end up getting M12L24. The beauty with this thing is, as you can see the structure on the right hand side, you have a cavity, you have a ball-like cavity inside, and that is covered by the anthracene moiety, and that gives some sort of very good, nice enclosure. So they further developed with a lot of beautiful host-guest complexation with this kind of self-assembled metal organic cages. So one interesting example, what they have done is, so our biological receptors, so they recognize the sex hormones, male hormone and female hormone, like testosterone, progesterone, and estradiol, these kind of hormones. Whereas none of the man-made receptors so far could selectively bind only one among them, selectively show some affinity towards only one. So this particular receptor readily obtained over a simple single step of reaction shows that it can selectively bind testosterone. So due to the nature of the aromatic molecule along the wall and the geometry of the testosterone over there, and they could demonstrate like a nice biomimetic affinity with the synthetic supramolecular receptor. Okay. Later, they they also demonstrated huge amount of host-guest applications with the system. So another one important application what they have demonstrated is, so this M2L4 host-guest M2L4 supramolecular receptor can selectively bind sucrose molecule. It's like a disaccharide. So what you see here is a sucrose molecule among all possible different sugar molecule. So it selectively binds sucrose molecule inside the cavity. So why one should bother about carbohydrate recognition? We have a synthetic receptor which can bind selectively some sugar molecule that has a lot of practical applications. Like our cell walls, they have a membrane, the cell wall, our body, we have a cell, and the cells have a lot of cell membrane proteins, and some of them are what we call lectin. So those protein molecules selectively recognize certain sugar molecule. So when the virus attack is happening, or bacterial attack, or even some cancerous cells are happening, so the first communication is the lectin protein, carbohydrate binding protein molecule and the selective sugar molecule over there. So the idea is, if you can make a synthetic receptor which can bind selectively certain carbohydrate molecules, and they can compete with the virus or cancerous events, so that you can use them as some sort of drug molecule over there. It's like a supramolecular receptor becoming a drug kind of approach. Still, there is no practical demonstration. It is like a hypothesis, and still a lot of people are hunting behind this kind of phenomenon. So this is one beautiful example. A man-made metal organic supramolecular cage is binding a sucrose carbohydrate molecule. Okay, so later they went little couple of steps further crazy. They made some bent, still longer ligand. So you have a bent ligand. Upon complexation, they end up getting a what they call like a peanut-shaped supramolecular capsule. So this kind of molecule is also the simple. We do some long ligand synthesis and mix it with metal ion. We end up getting metal organic cage. And what they demonstrate, they can encapsulate sugar C60 molecule inside the cavity over here. Okay, so now we talk about another different interesting example from China. Okay, so here what we see is a ruthenium based ligand and ruthenium phenanthrin complex, and they resolved it into two enantiomers. Then further they finally functionalized with the tripyridyl moiety over here, as you can see here. Both are two different isomers. Then upon mixing with the palladium ion, they obtained a metal organic cage. I think it is I don't remember the exact metal geometry, sorry. But what they got is, so they could get two separate chiral isomers of the metal organic cage. So when you put a mixture of guest molecule, mixture of guest molecules with R and S isomer, it selectively binds one among them. So when you have a R cage, or plus cage and minus cage, and it selectively binds only R isomer or L isomer. So another beauty with this ruthenium moiety over here is, so it can selectively absorb the light with a certain wavelength. Okay, so in this case, what they have done, they took the same cage molecule and encapsulated with acinaphthalene. So what you see here, this acinaphthalene over here. Okay, so once the acinaphthalene is kept inside, so it undergoes selective 2+2 photo reaction, and what they got is only one isomer, anti-isomer. So in principle, you can have both syn isomer as well as anti-isomer. And even when you go one step further, if you put one substitution, in principle, you may end up having like this kind of 6 different possible isomer, but what they got is only one selective anti-isomer. So this is like a catalysis in a confined position. So this kind of cage molecule, they are more like a molecular flask, a round bottom flask, but in a molecular scale. And you put the you do the reaction inside this cage molecule, so that the confined space is giving us the opportunity to do to get the very selective product out of the all other possible isomers. Okay. So this particular example is coming from Professor Dilip Chand from IIT Madras. So far, what we have seen is like a symmetrical cage molecule. So what they have done, so they took a mixture of ligands and they are kind of ester spaced. So as you can see, ligand 1, ligand 2, ligand 3, up to 6 such ligands. And this very recent example. So they did the complexation with the palladium ion, and they put all the mixture of ligands, and they undergo some sort of self-sorting to form thermodynamically more stable complex, what you see over here on the top. And what you see here is like a different cage moieties, they are co-joined with each other. Okay, further they have a different cavities inside. So one is selectively binding with chloride anion, other one is selectively binding with nitrate anion. So this is like a beautiful intellectual game, and they have demonstrated from this city. Okay, then there is one more research group in India, Professor Parthasarathi Mukherjee at Indian Institute of Science. What they have demonstrated, they also synthesized a nice, beautiful ligand design, and they ended up getting some certain beautiful barrel-like cage molecule. And further, they demonstrated the beautiful deal sort of cycloaddition with this cage molecule over here, as you can see over here. And another beautiful example for the catalysis is coming from someone called Professor Paul Lesby from England. So this is the very simple ligand, as you can see here. It's a very simple symmetrical ligand, and they mix it with palladium, and you get a M2L4 kind of cage molecule. So what they have demonstrated is they had shown this is a beautiful catalyst for a simple Diels-Alder reaction, because with a very high turnover number over here, like above 1000, this very remarkable catalysis by a man-made catalyst over here. Okay, so what is the hypothesis they provide is the catalyst is stabilizing the active transition state. That's the main feature. So when we talk about enzyme catalysis, the enzymes stabilize the transition state. They don't stabilize the substrate or not the product, but they stabilize the transition state so that you get the product out of it. Further, another important reason for this kind of man-made enzymatic catalysis, you have a host molecule and it should bind the substrate, and the product should not have a strong affinity for the host molecules. Otherwise, you form the product and the product stays there happily. Ideally, the product should come out of the system. So that is the main objective, main driving force for the catalysis. Okay, so here you have a substrate, they go there and undergo the reaction very selectively at very fast, and the product forms and it comes out, so that the next substrate keep going, so that you get the high turnover number. So this is the main feature of the enzymatic catalysis. And these are the very early examples of human reaching the enzyme-like activity for the catalysis over here using these kind of metal organic cages. Okay, this is another beautiful example from Professor Parthasarathi Mukherjee from IISc Bangalore. What they did, so far we have seen the ethylene diamine palladium or palladium nitrate. What they did, they took the chiral complex of the palladium source. Then they ended up seeing metal organic cage with selective chiral isomers. Okay, then they have demonstrated, here again they have demonstrated you can have a both delta or the other isomer of the cage molecule depending upon the palladium source what you are taking. Subsequently, you can use the cage molecule for the selective separation of the enantiomers from your racemic mixture. Okay, so now we move into some another interesting class of cage molecule from someone called Professor Kenneth Raymond from Berkeley. Okay, so far what you have seen, they are pyridyl nitrogen donor based ligand, and what they have taken is like a catechol moiety. What you see here, like a catechol moiety, and this is anionic ligand. So unlike the pyridine ligand which are all neutral, these catechol ligands are all anionic ligand, and this anionic ligand they undergo complexation with metal ions like gallium or titanium or even iron to form an anionic complex. What you see here is like a 12 minus, overall 12 minus charge of the ligand. So this is like an anionic cage stable in water, and you have a cavity inside. That cavity selectively binds cationic yeast molecules. So that is the fine feature of this cage molecule. Okay, so they have also demonstrated huge number of beautiful catalysis inside the cavity. So this one beautiful example is like Azaco rearrangement within the host molecule. So what as you can see over here. So don't elaborate. So now the time is running out. So I'm just moving further. So another example is like what they have demonstrated is like a orthoformate hydrolysis. What you see here, orthoformate hydrolysis, they undergo hydrolysis under acidic medium. But what they have demonstrated, they did the catalysis at very highly basic pH with high turnover number for the catalysis. So this is like you are performing a very competitive reaction in a very competitive solvent with beautiful enzyme-like catalytic activity over here. Okay, so now I move on to our little bit piece of work which we have done very recently, which I talk about a little bit further. So far what we have seen, most of the people, they took very symmetrical ligand, and they are more like a C2 symmetry or C3 symmetry, and they are of aromatic backbone. Okay, so what we thought, how about taking some aliphatic ligand, aliphatic backbone with little bit of flexibility therein, and as well as rigidity, and functionalize them with pyridyl moiety and try to get a metal organic cage. So in principle, so what we thought, we can take the cholic acid. This is a beautiful molecule, something called cholic acid. So this is what we get from the axe, if I'm correct. So give me 1 second. So what we thought, we can I'm just struggling with the monitor. Just give me 1 second, please. Yes, I'm back. So what we have taken a molecule called bile acids. They are available, they are excreted from our body liver. Okay, so what we have taken, cholic acid, deoxycholic acid, cheno-deoxycholic acid, and lithocholic acid. So they are kind of steroid molecule. We can get them very readily from the market, and they differ with each other by the lack of hydroxyl groups. What we see over here, the 3 positions, 7 position, 12 position over here. Among them, cholic acid is a very cheap one and readily available. So what we did, we functionalized the cholic, all these bile acids with the pyridyl moiety over here by forming an amide bond, as you can see. So this amide bond over here. So we form the pyridyl moiety over here. So then what we wonder, what will happen if we allow them to undergo self-assembly with palladium ion. So in principle, you can have a four different isomers in which so what we call, this is head position, whereas the other end is tail position. One is head, other one is tail. So in principle, you can have a multiple isomers, like all the head are on the same side, or 2 are on the one side, other 2 are on the opposite side in a different manner, or 3 of them. So like head, and head, tail, head, tail, or head, tail, like that kind of scenario. Okay. So we thought whether what will happen if we get only single product or multiple product, and is there any driving force to get only single product, how we can achieve some, because our objective is to get a single discrete isomer, not like a mixture of isomer. Still, that's the main reason people take highly symmetrical ligand, but we wondered what will happen if we take an unsymmetrical ligand. So we took the ligand, we made the ligand, and we took it and let it undergo self-assembly with palladium ion. Then we got the mass spectra. Mass spectra confirmed a single beautiful peak. So what we see here is a molecular ion peak. So this is the beautiful field to learn the mass spectrometry. So most of the time we see M by Z, and here the Z charge is like a 4+. So we get the overall charge divided overall the molecular weight divided by 4. So the real molecular weight is 641 into 4, as you can imagine over. Okay. Then even with the other ligands like a deoxycholic acid and lithocholic acid based pyridyl ligand, again we got the similar discrete molecular weight for those complexes also. But when we did the NMR analysis, so NMR tells whether you have a single molecule or a mixture of molecule. And so we did the NMR analysis. The NMR suggested that for the cholic acid based ligand only, we could get a discrete single product, whereas the other ligands, so they are like a mixture of products. They are too complex, but you have to do multiple 2-dimensional NMR analysis to confirm what is the stereochemistry. So we did the same. So it's a bit rigorous exercise what we have done. So what we have concluded that, so with simple cholic acid, we get a single discrete molecule, whereas the other different isomer, we get a mixture of complexes. Okay. So so I don't want to elaborate further here. And so this is another beautiful spectral tool, something called diffusion ordered spectroscopy. This is a very valuable NMR tool. So this tells that you can, from what you see on the x-axis is the simple 1D spectra, but what you see on the y-axis is like a diffusion, it's like a logarithmic scale of the diffusion coefficient. Okay, so in this figure, what you see, all the peaks are on the same line with certain value. So this tells that what you have in the reaction mixture is a single product, whereas the other cases you have something but they are not exactly in the same line. So suggesting that you don't have a single product, but you may have a mixture of product over here. So from this diffusion ordered NMR, you also get the diameter of the complex. So that is the by another way you can see the guess the what is the molecular size you are having in your hand. So this also conforms with what you are theoretically expecting over here. Okay. So we tried to get the crystal structure of the complex, but we couldn't get it. So then we did a very rigorous theoretical DFT-based analysis. Then what we found that when you have a complex in which all the head groups are on the same side, the one on the very left extreme, so that is more stable compared with the other isomers. Then we wondered what could be the reason and why it is happening with only one molecule, whereas not in the other ligands. Then what we identified that in the case of folic acid, you have the two extra hydroxyl groups, whereas in the deoxyfolic acid or ethofolic acid, you don't have the hydroxyl groups. So what we identified that here not only coordination-driven self-assembly, the additional hydrogen bonding between the functional groups present in the other part of the ligand, they are also playing a very crucial role. This is sort of hydrogen bonding allows you to undergo self-sorting among the different mixture to get a very simple, single, discrete isomer out of the multiple possible options. Okay, so this is what we have demonstrated recently. But ideally, one would do some sort of post-haste complexation inside the cavity. But what we observed that the complex is too big, but the cavity is too narrow, and inside the cavity is too less. And we tried, as well as when we try to do the NMR experiment, as you see here, the main where the ligand, whatever the guest molecule you can think of, and the NMR position, they are overlapping over here. So we couldn't demonstrate any post-haste complexation so far. And what we have demonstrated is like you can have interligand hydrogen bonding that can allow you to undergo self-sorting to get a single discrete isomer out of all other possible options. So finally I try to conclude, although we have a little bit of 10 minutes time, I try to conclude now. So the take-home message is coordination-driven self-assembly is a very powerful approach to get metal organic cage kind of molecules. So the molecules have very beautiful, nice cavity inside. And in principle, one can use them as a reaction vessel to perform different chemistries inside. So they can selectively trap highly reactive species like phosphorus in the water solution, and they can stabilize very reactive species like ammonium ions or even some other transition metal ions inside the cavity. And you can use them as a beautiful catalyst. And this kind of cage molecule can help you to separate the racemic mixture into get a single discrete isomer. And these are some of the examples coming out of this metal organic cage molecule. The field is very growing field, like it's still very early stage, but still very growing field. And a lot of people are working in this field over here around the world. So now if you would like to ask any question, please feel free to ask.
Participants, unmute your microphone and you can ask the questions.
Professor?
Yes, please.
Good evening, sir.
Good evening.
One of literature,
yes,
Jonathan
yes.
work.
Yes, yes.
Aldehyde with diamine. You just
yes.
told that imine is soluble in water.
Yes.
The imine, once
yes.
if you add a water, the
yes.
decomposition takes place, right? Reversible reaction.
In principle, but they also undergo coordination with the metal ion and they become stable.
Is it stable
yeah, it's stable in water. It's not a free imine. It is like a further it is coordinated with metal ion. So the reaction medium is water, but still they are stable.
Fujita cage type molecule.
Yes.
4:3 ratio, I think.
Yes. Yes.
Yeah. How they control the polymerization reaction?
Because this palladium, so what we see here is the ethylene diamine palladium, so that is kind of cis protection. So only two other possible binding geometries are available for the metallation, and that favors the discrete molecule over the polymeric molecule. So that's what the self-assembly is about. So you can have a polymeric as well as discrete, but the discrete molecule is becoming thermodynamically more stable over the polymeric one. So that favors the formation of discrete molecule.
Just one clarification from your work.
Yes, please.
if you recollect in your generation, the dendritic first generation, second generation, third generation, if you record NMR spectroscopy,
yes,
we won't get much difference in generation. Similarly,
yes,
the monomer, dimer, trimer, tetramer, if you
yes,
record NMR, we won't
yes,
get much difference in
yes,
NMR data. I think so.
yes,
So similar, same thing. MALDI and TOF mass spectrum, if you record, it's a trace amount of compound is enough to give a molecular ion peak. My suggestion is GPC is a better way. How many types of compound present in our product?
Okay, so the other way around, as I shown the dosy NMR. So you remember, do you follow? So the dosy NMR, so that also gives the molecular size.
Okay.
If you have a monomer, dimer, trimer, or some other species, you will have a multiple species on the y-axis. But what you see here, all the peaks are on the same line. So that tells that you have a single species of certain diameter, certain diffusion coefficient exists in the solution.
Oh, nice, nice. Excellent work, Professor. Congratulations.
This is well-known approach. It's not. It's this option. But the GPC is mostly synthetic polymer people perform. But in this case, I don't know. So I haven't come across anyone demonstrating GPC for this kind of metal organic cages. Solubility and the stability in the column, they also matter over here.
Okay. Nice, Professor. Thank you.
Natarajan.
Yes, sir.
I just missed your first part of your talk. I'm sorry.
It's fine.
So I don't know whether you have discussed about even ESA mass.
Yes.
Can give a, if it is a monomer, dimer, trimer, you could have got it actually. Did you get it actually?
This the DSA mass is like what we have is like a single discrete set of peaks. So we have a major molecular ion, and we may have a anion adduct species. Like we have a 4+ charge along with one anion together with two anions together. What we see in the below position, if you can see over here. But this also very standard technique to confirm what we have is like a single species or a mixture of something else. But in the gas phase, many things can happen. Like they can undergo fragmentation. Some of them may not be detectable, or like that also.
Yeah, but positive ion mode is okay. But if you switch the polarity to the negative, but I think you will not get only the counter anion you will be getting, but that will not tell you whether it is a,
in principle, yes.
Trimer, tetramer. Correct?
Yeah, but in this case, because the metal dictates the geometry, you cannot have a so you cannot have a monomer, dimer, trimer in principle. So metal means it needs a square planar geometry, it needs a 4 ligand. But except that, whether you have a mixture of other isomer or still bulkier species or smaller species, instead of M2 metal 4 ligands, you may have some 4 metal 8 ligand. But that will also show up in the mass spectra over here, the parent peak.
But sometimes we'll get with the water also into the water as adduct.
Yeah, definitely. We also seen some of them. I didn't hide it over here. We have a couple of the peaks with anion along with 2 water molecules.
Because with a simple, complex organometallic complex itself, we used to get it actually.
Yes, definitely.
Okay, thank you. Good.
Thank you.
Thank you, sir. Parasuram Jaishankar, sir. Thank you very much, sir.
Thank you, sir. Thank you very much.
Thank you, sir, for the presentation.
Any other questions from the participant side?
Yes, here, Dr. Sumathi.
Yes, please.
Please, ma'am.
Are there any reports
yes.
in using the self-assembly for trapping the harmful species like this coronavirus?
Virus size is too big. It's like these molecules, they are nanometer size, whereas the virus is like a micrometer, big micron size species. So, but maybe like a zeolite, I don't know. It's like this virus also new to us, so we don't know anything about it. So, and how much practically that is going to be feasible to trap them. Like the reason we wear mask is like we are trapping them from spreading.
Thank you.
Any other questions? Thank you, sir.
Yeah, it is actually 120 nanometer size actually, this coronavirus. Yeah. Thank you.
Okay. Thank you, sir, for the presentation.
Sir, your PPT is sharing.
Yeah, I need to stop it.
Thank you, sir, for the presentation, which was incredibly informative. Your clear presentation made your insights about the topic very well received by us. Thank you so much for the excellent presentation. Thank you.
Thank you, sir.
பார்த்துருந்தா கண்ணு பொட்டாயிடும், டிவி சொல்லலாம், கண்ணு போயிடும், புறம் வந்துடுமா, கண்ணில் எல்லா வியாதியும் வருமா. ஒரு மணி நேரம் பார்த்தா 15 நிமிஷம் 20 நிமிஷம் தள்ளி போயிட்டு
Unmute yourself.
இப்படி பார்த்துட்டு கண்ணு வலிக்கிறது, கையை கசக்குவாங்க, கசக்காம அந்த கன்ஜெக்டிவிட்டிஸ், அப்புறம் கேட்ராக்ட் எல்லா வேலையும் வருங்க. கண்ணு இல்லாம போனா ரொம்ப கஷ்டம். வேலையை விட்டுறாங்க, வேலையை விட்டுறாங்க, வேண்டாம் நீ வேலைக்கு போக வேண்டாம், இது பண்ணுவாங்க. இது கையை தொட்டு மூஞ்சியெல்லாம் தொட்ட எங்க என்ன இருக்குன்னு தெரியல. இப்பதான் 4 வண்டி போயிருக்கு இந்த பக்கம். நீ இதை போட்டா அதுவும் நல்லா கை கால அளவு மூஞ்சி வந்துதான் என்னால தாழ முடியாது, ஒன்னு ஏற்க முடியாது. என்னால தயவு செஞ்சு நான் கெஞ்சி கேட்கிறேன், வேர்க்கலை சாப்பிடுறதெல்லாம் கையெழும்பு சாப்பிட பண்ணா எனக்கு இல்லைன்னா கஷ்டம். அம்மா கவலை நீ தானே இருக்கணும். எனக்கு
முடிஞ்சு போச்சா
தெரியல, அது விட்டுட்டான். நீ கொஞ்சமா நீ என்ன தைரியம் இருக்கணும்.
தெரியாம அவளே மியூட் போட்டு பேசுறான், அவளே மியூட் போட்டு பேசிருக்கான்.
இல்ல அதான் சொல்றேன், நீ உடம்ப பாத்துக்கலாம் வச்சுக்கேன், ரொம்ப கஷ்டம். சாரி பயப்படாதேங்கிறான்.
That was a good, genuine advice in a way. Thank you.
Sir, thank you very much, sir. Very kind of you, sir. Thank you very much, sir. Thank you. Ma'am, Sonalakshmi, ma'am.
Yes, I am available.
Thank you, ma'am. Thank you, ma'am. Good afternoon, ma'am. Good afternoon, ma'am. We can start at 3 o'clock, ma'am.
Okay, no problem.
Another five more minutes are there.
Yes, I'll mute myself. Okay. After some time, I will.
Yes, ma'am. You have logged in with
after a long time, I'm seeing, after.
Yes, ma'am. Yes, ma'am.
5 years we met.
Irukkum, ma'am. 5 years. Tansky syllabus committee.
Yes. Syllabus. Okay, sir.
Ma'am, என்ன நேம்ல ரெஜிஸ்டர் பண்ணிருக்கீங்க மேம்? மேம் உங்களது நேம் டிஸ்ப்ளே என்ன நேம்ல வந்திருக்கீங்க மேம்? மேம் நீங்க என்ன நேம்?
சொர்ணலட்சுமினே தான் வரும் சார்.
சொர்ணலட்சுமிலே தான். ஓகே. ஆமா.
அண்ட் எங்களோட ஸ்டூடண்ட் பொச்செழியன்.
அவங்க கொடுத்துறாங்க மேடம்.
ஓகே. He said he will come at 2:45.
No problem. We have time.
Okay. So நல்லா இருந்தது, நைஸ் செஷன். I joined even for that session.
Thank you, ma'am.
Yes.
பொச்செழியனா மேம்? பொச்செழியன்.
ஆமா, பொச்செழியன்.
பாத்துறேன். Yes, he's available.
Available, no? Because he has to present the slides.
I know. He's available, ma'am.
Nice, sir. So I think this is a last relaxing session for everyone.
Yes, ma'am. Students are eagerly expecting about group theory, about your lecture about the group theory, ma'am.
It's okay, fine. But I feel compared to all the earlier presentation, this will be a just relaxing session.
Yes,
so they would have seen so many molecules.
Okay, ma'am.
If at all using this, they may try to put them in groups.
So, particularly point group.
That's the only group what we refer to in group theory.
Ma'am, HOD ma'am.
Madam? Oh.
Ma'am, HOD madam.
Yes, sir.
Ma'am, madam வந்துட்டாங்க madam.
Hello, how are you? After a long time, I'm seeing you.
Good afternoon, madam.
Good afternoon.
How are you, madam?
Fine. I think so many years I've gone, right? No?
Yes, madam.
No, at least Vijay Lakshmi and others I could see.
Yes, madam.
உங்க ஸ்டூடண்ட் எல்லாம் மேம் ஆக்சுவலி உங்க ஸ்டூடண்ட் இல்லீங்களா
in Sithalakshmi Ramasamy College. See, I think God has blessed us so much. So many of my students, they retired from their service, and many of my students' children, they studied with me.
Oh, fine, ma'am.
So even second generation I taught, not the first generation. Their children also. I got the opportunity to teach them.
Great, ma'am.
So maybe the wishes of my teachers. Maybe.
God's grace, ma'am. These are all the gift.
Yes, definitely. That's why I don't say no, but after seeing the invitation only, I got little, because even I would have gone for some research topic, but because you specifically asked for this.
Yes, ma'am. Group theory. We need group theory from you only, ma'am. That's the thing. From in the year of 1990 itself, ma'am. In the year of 1990 itself, we are following your the group theory topic, and even when I was studying in Jaman Mohammed College, ma'am, professor was there in St. Joseph College, Professor Raman.
No. After his book only, our book has come.
Yes, I got familiar.
But now I think most of the colleges they are following.
Oh, fine. Particularly the CSR and GATE aspirants are mainly following your book only. No?
Yes. Most of the colleges. Okay. I think in most of the Northern University also, they make it as a reference book, sir.
Oh, fine.
Anyway, so it is only our HOD's brainchild.
Our Professor Jaishankar sir also there, ma'am. Senior professor. Jaishankar sir. Yes, ma'am. This is number 2.
I know him, sir, very well. I know him.
Sorry, is available, ma'am.
Okay.
Sir, mute. Sir, Jaishankar sir, mute lurking, sir. Sir, mute lurking. Unmute பண்ணனும் sir.
Jaishankar sir, how are you?
Sir, unmute பண்றதுக்காக வெயிட் பண்ணிட்டு இருக்கேன்.
But my presentation will help them, sir. You can keep the slides. You can use the slides for the students.
Okay.
So without model even, I think the credit goes to Dr. Pocheya. He's going to be a doctorate, so I can even call him.
I think he is working in Vivekananda College, no?
No, in Guru Nanak College.
Guru Nanak College.
Yes.
Good afternoon, madam. Jaishankar.
How are you?
Fine.
I think you came as an examiner to Saubhagya Prabha. Appa paathadan illaya sir?
Examiner, seminar and the workshop.
Yes, sir.
The university, we worked together and the...
Yes, sir. So many things we did together, you know. And Uma also, our common friend.
Yes.
How are you, sir?
Fine, madam.
That's what I asked, sir. So finally, he has given me a nice, relaxing topic for all the students. From so much research, just is very small topic so that the participants can all relax with this.
Yes. Need such an expert person for me, madam.
Okay, sir. Let us see. And you are all doing very good job, very good contributing to this chemistry field.
Group theory relaxation சொல்ற ஒரே ப்ரொஃபசர் நீங்க தான் இருக்கறோம்.
It's a very simple topic, sir. This one. So see, the whole group theory, if I address to the student, then fine. It's only a time this piece we can do for them. But anyway, the teachers, especially the junior teachers, can use these slides. Then they can
really, yes, ma'am. Really, it will be useful for them also, ma'am.
Yes, yes, and students also for their self-study, they can use this model. With the model only we used to see. Your college even I have come.
Perfect.
Narayanan sir always used to call me every year for some lecture for NMR, for this group theory.
Group theory, okay.
And NMR also. So I have come to your college at that time when Dr. Narayanan. So that time, we used to make.
2010 only we came to Presidency, ma'am. Before that, we are not there. So.
Oh no. Okay.
So
okay.
2011 sir retired, I think.
Okay. So, yaar headship la neenga vandinga?
இவர் தான் மேம் நாராயண் சார் ஹெச்ஓடியா இருக்கும்போது தான் வந்தோம். பட் வந்து 1 இயர்ல அவர் ரிட்டையர் ஆயிட்டார்.
ஓகே. அதுக்கப்புறம் இவர் இருந்தார்ல சார்?
நான் ஒரு ப்ரோக்ராம் அரேஞ்ச் பண்ணிருந்தேன். அதுக்கு வந்து நீங்க தான் குரூப் தேர் லெக்சர் கொடுத்தீங்க.
என்னங்க சார்?
ஒரு லெக்சர் ஒன்று கொடுத்தீங்களா? 2014 கொடுத்தீங்க.
ஆமா, என்ன மாதிரி என்னமோ கொடுத்தோம்ல சார்?
சார் குரூப் தேரி ஆல்சோ குரூப் தேரி தான்.
ஓகே 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 ஓகே. நாங்க ஒரு தடவை ஸ்கேரியா ஒரு ஸ்டார் கேஸ்ல வேற நடந்தோமே சார். கன்ஸ்ட்ரக்ஷன் வர்க். ஐயோ ஐ ஸ்டில் ரிமெம்பர் தட். எஸ்.
பிரசிடென்சில கெமிஸ்ட்ரி பிரசிடென்சில கெமிஸ்ட்ரி டிபார்ட்மென்ட்க்கு வரவங்க அந்த ஸ்டார் கேஸ் மறக்க மாட்டாங்க மேம். பயந்து ஏறுவாங்க.
கேரி தட் டியர். ஐயோ. எஸ்.
Ma'am, shall we start, ma'am? Ma'am, actually, ma'am, start பண்ணிடலாம்.
Yes, sir. We can start.
Yes, ma'am. Yes, ma'am. Ma'am, WS, ma'am. WS, ma'am, is the master of ceremony, ma'am. Uma, ma'am's best friend. W. Shanti. Dr. W. Shanti is there.
She used to tell her name so many times.
Yes, ma'am.
I remember.
Both of them are very good friends.
I know. Then everyone, all of you are very good friends only. I know that.
Thank you, ma'am. Start.
Well, the last presentation of the webinar is on the topic Group Theory, Point Group Classification by Professor Dr. Swarnalakshmi Chandran, Emeritus Professor, Guru Nanak College, Chennai. Dr. Swarnalakshmi Chandran has 36 years of teaching experience and is well known for her expertise in group theory. Her exemplary book on group theory makes the subject more simple and interesting, which is used by almost all the CSIR aspirants. Hope this session will be beneficial to all, particularly to the students attending this session. Thank you, ma'am, for being with us here today. And I now leave the floor to Dr. Swarnalakshmi Chandran for the presentation. Please.
Thank you. Thank you, ma'am. Good afternoon to everyone.
Good afternoon, ma'am.
It's a wonderful opportunity to share the preliminary aspects of group theory with young minds. So I am thanking Principal, HOD of Chemistry, faculty of all the faculties of Chemistry Department, especially Dr. Muthukumaran, for inviting me and giving me beautiful platform to share the basics of this group theory. So first of all, what is this group theory? To understand this group theory, you have to understand, first of all, what is symmetry. So the general meaning of symmetry, it's uniformity, regularity, evenness, orderliness, proportionate, etc. So we can keep on adding many adjectives like this for this symmetry. So nowadays, we all know that symmetry plays excellent role in maths, physics, chemistry, everywhere. So it plays a vital role in chemistry also. And we say, normally, if an object exhibits symmetry, if it looks the same after some mathematical transformation. So whenever we do some mathematical transformation on any object, if the object exhibits the similar appearance, then we say that the object is having the symmetry. So we all know the symmetry of the butterfly. So it has a bilateral symmetry like human being. We are all having the bilateral symmetry. Today, let us come to the role of symmetry in chemistry. So what we do in chemistry is, we are more focusing on our molecules. So the molecules, they have different geometry. So normally, we are taking into account the covalent molecules. So they have different geometry. So depending upon the geometry, the molecules are going to have different symmetries. And depending upon the symmetry of the molecule, we can classify the molecules into groups. Because normally we chemists, we want to make our studies easier by doing simple classifications. So you all know about the periodic classification. So like that, in group theory, based on the symmetry elements or nature of the symmetry present in the molecule, we are trying to classify the molecules into groups, but are specially called as point groups. So you can clearly understand that molecules with different geometry will have different symmetry elements, and molecules with different symmetry elements will belong to different point group. Now, how to identify the symmetry elements present in the point molecule? So what we are going to do is, we are going to perform suitable mathematical operation, like simple operations like reflection, or we are going to do inversion, or we are going to do rotation. So by performing the appropriate symmetry operation on certain geometrical entities present in the molecule, and if the molecule is going to present an indistinguishable configuration, we say that the molecule has symmetry elements. Or I'll repeat in a simpler way. We are choosing some geometrical entities in the molecule. So what are all the geometrical entities we are going to choose? It can be the planes present in the molecule, or it can be the axis, or it can be the center of the molecule. So these geometrical entities can be simply geometrical entities, or these geometrical entities can become the symmetry elements. So when can the geometrical entities can become the symmetry elements? When they are going to present an indistinguishable configuration, when we perform a suitable mathematical operation, we say that, that the geometrical entities have become the symmetry elements. Then, what is an indistinguishable configuration? You know, configuration is nothing but a spatial arrangement. Indistinguishable configuration means the original spatial arrangement and the spatial arrangement obtained after the operation, mathematical operation, if they are similar, then we say that the molecule is presenting an indistinguishable configuration. So the whole process, I can put it this way, we are choosing the molecule, choosing the geometrical entity, performing the appropriate symmetry operation, then we are arriving at a configuration or a spatial arrangement of a molecule. If the original configuration and the configuration obtained after the symmetry operation or after the mathematical operation remains the same, then the mathematical operation becomes the symmetry operation and the geometrical entity have become the symmetry element. So it is understood that to identify the symmetry elements, you need to know the appropriate symmetry operation. For example, we are choosing the symmetry element as identity element, and the corresponding symmetry operation is doing nothing. Naturally, when we don't disturb the molecule, the molecule will continuously present an indistinguishable configuration. So that symmetry element is indicated by E. So all the molecules are going to have this identity element represented by E. Then next one is the proper axis of symmetry. So this is the name of the symmetry element. So what is the geometrical entity we are going to choose? We are choosing some axis present in the molecule.
Ma'am, audio varala, ma'am. Mute. Thank you, ma'am.
So now, the respective symmetry operation is, we are going to do the rotation about the axis to an angle of 2 pi by n degree. So after this rotation, if a molecule presents an indistinguishable configuration, then the axis chosen, we call it as a proper axis of symmetry of the order n, and that is indicated by Cn. So n is an order, so which is having the value 1, 2, 3, 4, etc. Then if n is 2, it represents a C2 axis. When n is 3, it represents a C3 axis, and so on. We are going to see in the later on slides. The next one is the mirror plane symmetry. So here we are choosing some planes present in the molecule. Then the respective symmetry operation, what we do is the reflection. So we have to imagine a double-walled mirror to be kept on the plane, and then when we do the reflection about this plane, when we get an indistinguishable configuration, then the plane chosen happen to be the symmetry plane. Otherwise, it is simply a plane of the molecule, and this is indicated by the symbol sigma. Then, next one is the center of the molecule we have to choose. Then, with respect to center of the molecule, what operation we have to do is, we have to invert the coordinates of all the atoms present in the molecule. So, after the inversion of all the coordinates for all the atoms, when the molecule presents an indistinguishable configuration, then it is no more a center of the molecule. It is additionally called as center of inversion present in the molecule, indicated as I. Then, next one is the improper axis of symmetry. Now, what is a symmetry operation? Here you have to do two symmetry operations. One is, we are choosing an axis or a line present in the molecule. So, about an axis, we have to rotate to an angle of 2 pi by n degree. Then, followed by that, we have to do the reflection about the plane perpendicular to the originally chosen axis. So, rotation followed by reflection about the perpendicular plane. If that is going to give the indistinguishable configuration, then that is called as an improper axis, and it is going to be indicated by Sn. Now, here I would like to make one extra information also. So, in some molecules may have the proper axis of symmetry as a symmetry element, and along with that, it is going to have the perpendicular plane also as the symmetry plane. When both are present, automatically one followed by another will also give an indistinguishable configuration. Naturally, because rotation itself gives me an indistinguishable configuration, then reflection also going to give me the indistinguishable configuration. So the combined operation invariably going to lead to the presence of improper axis of symmetry. Whereas there are other examples where the molecules are not going to have the proper axis as a symmetry axis, and then they are not going to have the perpendicular plane also as a symmetry plane. In spite of it, the combined operation is going to leave the molecule in an indistinguishable configuration. So in that case, definitely the molecule is going to have Sn axis even in the absence of Cn and also the perpendicular plane. Then we are going to discuss about all the symmetry elements in little more detail. So first one is an identity element. As I have told you, when we don't disturb the molecule continuously presents not even a indistinguishable configuration, original configuration itself, the molecule continuously present. So all the molecules will have the identity element E. Then this is only symmetry element present in the molecule with a chiral center. So a compound with an asymmetric carbon will have only identity element as the symmetry element. Then next one is the C2 axis. We can go to the proper axis of symmetry. So the simplest example is the C2 axis. And we can choose a very simple water molecule. So Dr. Pocherian is beautifully showing. So we can think of a rotation about that middle oxygen atom to an angle of 180 degree, like that, about an axis. When we do the rotation through 180 degree, what will happen? The left-hand side hydrogen will come to the right-hand side, and the right-hand side hydrogen will come to the left-hand side. So, but for the number 1 and 2, we cannot differentiate the two hydrogen atom. So, the rotation through 180 about an axis passing through oxygen atom and bisecting the line joining the two hydrogen atom will definitely present an indistinguishable configuration. So, this axis is referred to as a C2 axis. Now, the molecule can have C2 axis, C3 axis, C4, C5, C6, C7, etc. And there are molecules with more than one proper axis of symmetry also. So, when we are dealing with a molecule with more than one proper axis, the higher ordered axis, we can refer it to as a principal axis of symmetry. So, principal axis present in the molecule is the higher ordered proper axis of symmetry. Now, we'll take the BCl3 molecule. Now, we can think of a C3 axis. So, how the C3 axis will be? C3 axis will pass through only boron. And you know that this is a planar molecule. So, boron and all the 3 atoms are going to be lying on the same plane. So, when we can think of an axis passing through boron and remaining perpendicular to the plane of a molecule, so he's showing, so the C3 axis will remain perpendicular to that. So, about that, when we do the rotation through 120, so we'll do that BCl3 and then we'll come to this ammonia. So, when we do the rotation about an axis passing through boron to an angle of 120, what will happen is the top chlorine, the left-hand side, the right-hand side chlorine will come down because we are having the 3 chlorine atoms at an angle of 120. The rotation through 120 degree can definitely present an indistinguishable configuration. So, BCl3 has a C3 axis. And apart from that, BCl3 has 3 C2 axis also. So, how to show the C2 axis of this BCl3? So, he's beautifully showing a C2 axis passing through boron and one of the chlorine atoms. So, about the axis, when we do the rotation through 180 degree, what will happen is the 2 hydrogen outside the axis, 2 chlorine outside the axis will be exchanging the position. So, you are going to have an indistinguishable configuration. So, BCl3 has one C3 axis and also it has 3 C2 axis. How 3 C2 axis? Because every C2 axis is passing through boron and 1 chlorine atom. Because 3 chlorine atoms are there, you can think of 3 C2 axis going to be lying on the molecular plane of the molecule and your C3 remaining perpendicular to the plane of a molecule. Now, just now I have told you, whenever so many ordered proper axes of symmetry are present in the molecule, then the higher ordered axis is referred to as a principal axis. So, in BCl3, C3 and C2 are there. So, C3 is referred to as a principal axis of symmetry. Then, so below that beautiful presentation of your ammonia is there. So, the blue ball is nitrogen and the 3 hydrogens, H1, H2, H3. So, when we do the rotation through 120 degree, so it's a beautiful presentation. So, what happens is 1 will come to the place of 3. So, 3 will come to the place of 2 and 2 will come to the place of 1. So you are having an indistinguishable configuration. It is not the original one, it is an indistinguishable configuration. But for 1, 2, 3, you cannot say which is original and which is obtained after rotation. So such a configuration only, you call it as an indistinguishable configuration. And this is called a C31. What is C31? Rotation through 120 about an axis. We have done only one time. Then 120 has presented, 120 rotation has presented only an indistinguishable configuration. But we can think of one more 120 degrees rotation. So now what happens? 2 has come to the place of 1, 1, 3, 1 is coming to the place of 3. So you can see the next indistinguishable configuration, and that is indicated as C32. So what is the real significance of C32? C3 done 2 times. What is C3? C3 is rotation through 120. And if it is done 2 times, that is equivalent to rotation through 240 degree. So again, we are having only an indistinguishable configuration. Now, we are moving to one more 120 degrees rotation. Now, what happens is we are getting C33, and that is presenting the original configuration. You can see hydrogen 1 on the left-hand side, hydrogen 3 on the right-hand side, and hydrogen 2 above the plane. So, I can mathematically say C33 is equal to E. So, E indicates the original configuration in group theory. It's an identity element, or it is nothing but the original configuration. So what is the real significance of this equality? So when C3 operation is done 3 times, we are going to have the original configuration. So we can say that a C3 axis is associated with 2 symmetry operation or 2 symmetry elements. One is C31, another one is C32. Because someone will do it simply 120 degrees rotation. Some person can do 240 degree rotation. So both can present an indistinguishable configuration. So we say that C31 and C32 are the associated operations of a C3 axis. C33 we don't have to write because that is equivalent to E, or that is corresponding to the original configuration. So every molecule is going to have E. Already we have listed it. That is why a C3 axis associated with C31 and C32. Similarly, when we extend it, C22, when we take a C2 axis, we have C21. C22 is equal to E. So we don't have to do it. So C2 axis associated only with C2 operation. The next one is, so C4, the square planar HCl4 molecule. So beautifully it has been shown here. So HCl4, the square planar molecule. So you can think of a C4 axis. So what is C4? It is a planar molecule. Xenon and all the fluorine present on the same plane. It's a planar, square planar molecule. Then you can think of a C4 axis. So passing through xenon and remaining perpendicular to the plane of a molecule. So beautifully is showing the axis. So about that axis, when we do the rotation, what happens is the 4 fluorines, what are present along the square plane at an angle of 90 degree at the center, will be exchanging the position. So you are going to have an indistinguishable configuration. So that is a C4 axis. Now, a C4 axis is going to be associated with C41, C42. What is C42? Rotation through 90 repeated twice. That means 180 rotation. So 180 rotation, we can mark it as even C2. That is why in the slide it is marked as C4, C2. What is C2 is C42. So the same C4 axis is also a C2 axis because it is equivalent to C4 done 2 times. Then along with that C43 will also be there. C44 is equal to E. We don't have to separately show. And along with the C4 axis, the molecule has 4 more C2 axes also. So what are all the 4 more C2 axes? So 2 diagonal C2. So beautifully showing. So 2 diagonal C2s are there. Then two more C2s. So how the C2s? So the picture clearly shows. So the C2 will pass through xenon and bisecting the adjacent chlorines on both sides. So you could see a line. So two C2s are marked. So that is one C2, then other C2 this way also. So four C2s are there. In this four C2, two of them are diagonal and two of them are going to be passing through simply xenon and bisecting the line joining the adjacent fluorines on both sides. So four C2 axes are there, and all the four C2s, they are all lying on the molecular plane, and C4 is remaining perpendicular to the molecular plane. So this is with regard to xenon fluoride. The next one is, so we have seen this proper axis of symmetry. Now we'll pass on to symmetry planes. So we have to choose some planes present in the molecule. So simplest example is only where water molecule. So water molecule has two planes. So beautifully it is shown. So one is the molecular plane. So what is the molecular plane? The plane passing through oxygen and the two hydrogen. It's a plane or molecule. Oxygen and two hydrogen atom lying on the same plane. So you can think of a plane bisecting oxygen and the two hydrogen. So about that plane, when we do the reflection, what will happen is the top side lobe of the atoms will go to the back and vice versa. So again, the molecule is going to present only an indistinguishable configuration. So molecular plane itself is going to be the symmetry plane. Then one more plane is also going to be there. What is that plane? So that plane is passing through oxygen and bisecting the line joining the two hydrogen atom. So such a plane is also, so he is clearly showing that one. See, that picture itself is very clear. Yes. So it's a beautiful plane. So passing through oxygen and bisecting the line joining the two hydrogen. So about this, when we do the reflection, the two hydrogens are going to be exchanging the position. So the molecule is going to present an indistinguishable configuration. So this is one symmetry plane present in the water molecule. Another one is a molecular plane. And then we'll see some more example. So the next one is the ammonia molecule. I can, because the time is not there. So now the symmetry planes, you can classify them into actually 2 or 3 types. So one is sigma H. Other one is sigma V. Then one more extra, you can take it as sigma D also. So we can have 3 types of symmetry planes. One is sigma H. So what is sigma H is the symmetry plane, what is remaining perpendicular to the principal axis. That is called as sigma H. So they are called as horizontal planes in group theory. So immediately don't come to the conclusion it is going to be present horizontal, not at all. So it has a different significance in group theory. The planes, what are remaining perpendicular to the principal axis, that is called as sigma H. Whereas the planes which are containing the principal axis, they are called as sigma V. Then one more type is sigma D. What is the terminology given for that plane is the plane which are bisecting the adjacent C2 axis, they are called as the dihedral planes sigma D. So these are all the 3 types of symmetry planes present in the molecule. Now we'll take your water molecule. So water molecule, just now we have seen it contains 2 planes. One is a plane passing through oxygen and bisecting the line joining the 2 hydrogen. Then other one is a molecular plane. Now, if you take both the planes are going to contain the C2 axis. So from the slide, easily you can see that it's a molecular plane. He's showing also. So it contains a C2 axis. So the plane is only sigma V. Similarly, the second plane also contains the C2 axis. So because of that, both the planes in water, they are referred to as only sigma V. Then we are coming to this benzene molecule because benzene only, it's a beautiful molecule where you can have all the 3 types. Now, you know that in benzene, the principal axis is a C6 axis. which will pass through the center of the molecule. It's a planar molecule. So it has a molecular plane as one of the symmetry planes, and your C6 axis will remain perpendicular to the plane of the molecule. So about the center of the molecule, when we do the rotation through 60 degree, you know that the molecule will continuously present an indistinguishable configuration. So it can have C61, C62 up to C65. Now, C6 is a principal axis. Then what about the molecular plane? Just now I have told you the axis itself is going to be remaining perpendicular to the molecular plane. Now I am giving the reverse statement. The molecular plane remains perpendicular to the principal C6 axis. So the molecular plane in benzene has become the sigma H, or it is called as an horizontal plane. Then apart from that, it contains 6 sigma V, or it contains sigma V and sigma D also. So what are sigma V? So the slide beautifully gives you. So you can think of a plane passing through the opposite, diagonally opposite CH. So he's showing beautifully. So this is one of the sigma V. Now it contains the principal axis. So the plane. So plane means it's a three-dimensional projection above and below. So C6 axis will pass through the plane. That is why we say it is a plane containing the principal axis. So it becomes sigma V. Then next one in the slide, it is shown as sigma D, because the sigma V, if you consider the plane joining the diagonal CH, you call it as a sigma V. Whereas the same diagonal CH, if you join them as a line, it becomes a C2 axis. So diagonally opposite CH, if you join them as an axis, it becomes a C2 axis. About that axis, if you do the rotation through 180, the molecule presents an indistinguishable configuration. So if you take the sigma D, what is shown in the diagram, that is bisecting the two adjacent C2, that is why it has become the sigma D. So benzene is an example where you are having sigma H, sigma V, and also sigma D. Then next one is the inversion, center of symmetry. So we have to take the center of the molecule. With respect to center, when we do the inversion, if a molecule presents an indistinguishable configuration, we say that it is no more a center of the molecule, it is a center of symmetry of the molecule. So beautiful example is your octahedral molecule. So the essential condition for a molecule to have the center of symmetry is diagonally opposite atoms should remain the same in the molecule. So it very well it's satisfied in your octahedral molecule. So with respect to center, if you invert all the coordinates, then also you are going to have an indistinguishable configuration. Then your linear carbon dioxide molecule. So it also has the same atoms present on the diagonally opposite side. Then benzene. In benzene, diagonally opposite atoms are remaining the same CH diagonally opposite. So with respect to center, if I do the inversion, so diagonal atoms are going to be exchanging. If they are same, the molecule will definitely present an indistinguishable configuration. So the condition for the molecule to have the center of symmetry is presence of identical diagonal atoms. So if you have the same atoms in the diagonally opposite position, then even when you do the inversion, the molecule will present an indistinguishable configuration. So the center of the molecule will become a center of symmetry. So it is going to be indicated as I, and I, if it is done for the second time, it will lead to the original configuration. The next one is the improper axis of symmetry. So the time is very less. Now I have already told you there are molecules with the Cn and sigma that will lead to Sn. Whereas now I am giving a different example where the molecule is not going to have the Cn axis as the symmetry axis. In spite of it, that axis will remain as an Sn axis. So the beautiful tetrahedral molecule, you can take it. So tetrahedral molecule has only C3 axis of symmetry, whereas it is not having a C4 axis, whereas it has an S4 axis. So it is beautifully shown in the slide. So we are expecting an axis to pass through carbon, the middle atom, then bisecting, the axis will bisect C and D on the left-hand side. And the axis will bisect A and B on the right-hand side. So actually A and B are vertically up and down, whereas your C and D are the horizontal atoms. So you can think of an axis as, so he's beautifully showing, so it is bisecting C and D on the left-hand side and A and B on the right-hand side. So about that, when you do the rotation through 90 degrees, what will happen now? We are not going to have an indistinguishable configuration. We are having only a distinguishable configuration. So what happens now? Horizontal substituents have become the vertical substituents and vertical substituents have become the horizontal. That is what you are able to see. A and B has become horizontal now and C and D have become the vertical substituent. So we don't have an indistinguishable configuration. Now, we are going to do the reflection about the perpendicular plane. So the plane is beautifully shown. So the plane remains perpendicular to the originally chosen axis. So about that, when we do the reflection, now what will happen? So whatever you see on the left-hand side, that comes to the right-hand side. Whatever you have on the right-hand side, that will go to the left-hand side. So you are going to have again an indistinguishable configuration. It is not the same configuration because A, B, C, D, they are all interchanged. But you are able to see an indistinguishable configuration. So this is an S4 axis present in a tetrahedron molecule. So that is what the bottom picture also clearly, that is another way of presenting your S4 axis. Then next one is, so now we have seen all the symmetry elements, what can be present in a molecule. Next one is, we have to classify, we have to identify all the symmetry elements present in the molecule by doing the appropriate symmetry operation. Then we have to classify the molecules into groups to make our studies easier. And such a group where we are collecting or where we are doing the classification based on the symmetry elements present in the molecule, and that is referred to as a point group. And just like that, we cannot do the classification. Any group has to mathematically obey the rules for the formation of a group. Because the time is not there, I have not given, but I can give you what are all the simple rules only for the formation of a group. The first condition is there should be the presence of an identity element. Just now I have told you all the molecules invariably going to have the identity element. The next one is the binary product of any two symmetry elements should also be a member of a group. For example, if I say that there is one sigma V, there is one C2, then the product of C2 with sigma V done in both ways should also be a member of a group. So if I do, generally if I take X as a symmetry element, Y as a symmetry element, the product of X and Y, if it is equal to Z, then Z should also be a member of a group. So like that, X and Z should also be a member of a group, Y and Z should also be a member of a group. So the binary product of all the members of a group should also be the member of a group. Like that only we can do the classification of, or we can bring in the symmetry elements and form a point group. Then these groups are indicated as a separate symbol, special symbol, what are called as shoe and fly symbols. Now, these are all the point groups available. So, Dr. Pocherian has beautifully given the flow chart to identify the point group. So, we are considering it's a simple way. Otherwise, just now I told you have to identify all the symmetry elements. Then, if you start identifying, performing all the symmetry operation one by one and identifying the symmetry element, then it will not take, it becomes a cumbersome process. It will take a very long time to complete the process also. So instead of that, we are following this flow chart to identify the point group in a simple way. So this flow chart, any CSR aspirant should have in the mind, because every year 2 marks, 2 to 4 marks, they are asking the point group of a given molecule. So the flow chart you can follow like this. So first question or first information what you have to find out is whether the molecule is linear or not. If the molecule is linear, then we have to follow the left-hand side of the chart. Then next question or next information or what you have to find out in the molecule is whether center of symmetry is present in the molecule. If the answer is yes, then you don't have to search for other things. You can write the point group as D infinite H. That's all. So linear molecule with I belongs to D infinite H. Then it's a linear molecule, but I is not present. Then the point group is C infinite V. Okay. Then so linear molecules only have two options. It belongs to either D infinite H or C infinite V. Condition is if I is present, D infinite H. If I is not there, then it belongs to C infinite V. Then if a molecule is not linear, then we have to follow the right hand side flow chart. So next what we have to find out is whether any proper axis with order greater than 2 present in the molecule, and that too more than 1 CN. So we have to find out whether it contains more than 1 C3 axis, more than 1 C4 axis, or more than 1 C5 axis, or more than 1 C6 axis, etc. We have to find out. So if more than 1 CN with N greater than 2 present, then we have to find out whether molecule has center of symmetry. So if the molecule has center of symmetry, then we have to find out whether it contains a C5 axis. If C5 is also there, the molecule belongs to icosahedron point group IH. IH is a Schwann-Fly symbol. So to identify IH, what are all the things we need? It is a nonlinear molecule and it has a C5 axis, more than 1 C5 axis, and it has center of symmetry. So if all these things are there, then the molecule belongs to icosahedron point group. Then the molecule has more than 1 CN and it has I also, but it is not having C5, it has only a C4 axis, then it belongs to an octahedron point group. So C4, more than 1 C4 with I is octahedron, I and more than 1 C5 is your icosahedron. Then if I itself is not present and if it contains a CN where N is greater than 2, then it belongs to tetrahedral point group. Normally a tetrahedral point group will contain 4 C3 axes. So more than 1 C3, 4 C3 tetrahedron, then C4 octahedron, C5 icosahedron. Then if the molecule is not having more than 1 CN with N greater than 2, then we have to find out whether CN is, at least 1 CN is present or not. If CN is present, then we have to find out whether N perpendicular CN are present. So CN is normally, it's a principal axis. Or the higher order axis only we call it as a principal axis. So along with CN, we have to identify whether N number of perpendicular C2 present or not. So if that is present, then we have to identify whether sigma H is also additionally present. If the answer is yes, it belongs to DNH. So what is a DNH point group? So it's a nonlinear molecule. Then it contains a CN axis. And then it contains N number of perpendicular C2 also. And then it contains one sigma H also. Therefore, it belongs to the point group DNH. Now, sigma H is not there. Then we have to find out at least when N number of sigma D dihedral planes are present. So instead of sigma H, if N number of sigma D planes present, then it belongs to the point group D and D. Now, if n number of sigma d also absent, the molecule belongs to the point group Dn. So what is a Dn point group? So Dn is a nonlinear molecule, one proper axis Cn along with that n number of perpendicular C2. Therefore, it is belonging to the point group Dn. Then next one is the molecule has Cn but no n perpendicular C2. In that case, at least identify whether sigma H is present in the molecule. If sigma H is present, the molecule belongs to the point group CNH. Whereas, if sigma H is absent, then we have to identify whether n number of sigma V are present. If the answer is yes, the molecule belongs to the point group CNV. If sigma H is absent, n number of sigma V also absent, then identify at least whether there is a S2N axis, improper axis. If that is present, the molecule belongs to the point group S2N. Whereas, if S2N is also absent, only CN axis, then the molecule belongs to the point group CN. Then, we have to go to the original one. No CN axis even present. In that case, identify whether at least one symmetry plane is present. If symmetry plane is present, then it belongs to the point group CS. Then, sigma is not there. At least check whether center of symmetry is there. If I is there, then it belongs to the point group CI. Then, sigma also not there, I also not there, then it belongs to the point group C1. Just now I have told you, all the molecules with an asymmetric center, a chiral center, that belongs to the point group C1. So this is a simple flow chart. What you can follow appears simple, but if you read it 2 or 3 times, definitely you will get it. And then with this chart, if you start practicing for the molecule, definitely you can easily classify the molecules into point groups. So many slides we have made it. So next one, we'll start with the linear molecule. So we'll take the HCN or carbonyl sulfide. So you can think of this is a linear molecule, but it has no I. The condition for I is the diagonally opposite atom should be different, should be same. Now in this molecule it is remaining different, so no I is present in the molecule. So already the point group is given as C infinite V. Now you have to understand what is a C infinite axis. What is the meaning of C infinite axis? Because I have not told you this. Now it's a linear molecule, H and Cn. Okay. Now an axis passing through the linear bond, the bond axis. So bond axis is going to be a C infinite axis. What is meant by C infinite axis? Rotation about this axis to any angle will present an indistinguishable configuration. So you can rotate through 1 degree, 2 degree, 3 degree, up to 360 degrees. You do the rotation through any degree, the molecule will continuously, because it is spherical. The atoms are being assumed to be, visualized to be the spherical atoms. So about this axis, when we do the rotation to any angle, the molecule will continuously present an indistinguishable configuration. That is why we refer it to as a C infinite axis. Then along with that, you can think of infinite number of sigma V also. So about the bond axis, you can think of any number of planes, symmetry planes. You can cut this into the entire 360 degrees are there. You can think of so many planes passing through this bond axis, and all of them happen to be the symmetry plane. That is why it belongs to C infinite V. Whereas you take your carbon dioxide molecule, acetylene molecule, now it has a center of symmetry. So the same infinite axis and same infinite number of sigma V, along with it is going to have infinite number of C2 also. Because you can imagine a plane what is bisecting the molecule exactly into 2 halves. So about the plane, you can think of infinite number of C2s going to be existing. That is where it belongs to the D-type point group. And then sigma H is also going to be there because that plane is also going to be a symmetry plane, what is remaining perpendicular to C infinite axis. That is why it belongs to the point group D infinite H. Then these two are the point groups for the linear molecule. Now, we'll take this molecule. What is this molecule? Bromochlorofluoromethane. So, we would have studied this as an asymmetric molecule. So, no symmetry element other than this identity element. So, this belongs to the point group C1. So, like that, by simply looking at certain symmetry operation, you can write the point group of a molecule. So, CSR aspirants and the competitive examination who are all preparing for the competitive examination, this is the easiest way to identify the point group. Then you take the quinoline molecule. So, it is a planar molecule. So, the molecular plane happens to be only one symmetry plane present in the molecule. So, this belongs to the point group CS. Then, next one is the mesotartaric acid and also 1,4-dibromo-2,5-dichlorocyclohexane. Molecule appears complex in the chair conformation we are given. So, now both the molecules are going to have the center of symmetry, because you can see the diagonally opposite atoms. So, the two green balls and the two red balls. So, diagonally opposite atoms are all remaining the same, both in mesotartaric acid and also this 1,4-dibromo-dichlorocyclohexane. So, because of the identical atoms which are present diagonally opposite to each other, the molecule has the inversion symmetry. So, these two molecules belong to CI point group. The next one is CNV point groups. So, simple example is your water molecule and cis-1,2-dichloroethane. So, in water molecule, we have seen the C2. So, whenever one water molecule has only one C2 axis, no more C2 axis present in the molecule. It's a non-linear molecule with one C2 and then 2 sigma V. So, already we have seen 2 sigma V in water molecule. One is a molecular plane, another plane is passing through oxygen and bisecting the line joining the 2 hydrogen. That is why water molecule belongs to C2B point group. Same story with your cis-1,2-dichloroethane. So, you can think of a C2 axis bisecting, passing through CC double bond. So, about this, when we do the rotation, the 2 chlorines will be interchanging, 2 hydrogen will be interchanging. So, that is a C2 axis. And this also contains 2 sigma V. One is a molecular plane, it's a planar molecule. So, plane itself contains axis. Another one is, instead of considering as an axis, you consider as a plane and then do the reflection, you are going to have an indistinguishable configuration. So, both these molecules will belong to the point group C2V. Then next one, ammonia, it belongs to a C3V point group. What's the condition? See, what you have to look into is, molecule has a C3 axis passing through nitrogen and the center of the corner, center of the triangle joining the 3 hydrogen. Yes, that is a C3 axis. When we do the rotation about this, the 3 hydrogen atoms are going to be interchanging. So, you are going to have a C3 axis. Then, 3 perpendicular C2s are not there. Instead, it has a 3 sigma V. So, the sigma V will pass through nitrogen and 1 hydrogen and bisecting the other 2 hydrogen. So, like that, because you have 3 hydrogen atoms, as he is showing beautifully, because 3 hydrogen atom and every symmetry plane will pass through nitrogen and 1 hydrogen atom, you are going to have an indistinguishable configuration. So, ammonia belongs to C3V point group. The next one is your xenon oxytetrafluoride. Now, this belongs to a C4V point group, because you can think of a C4 axis. Which is a C4 axis? An axis passing through xenon and oxygen. So, oxygen will be remaining perpendicular to the plane in which the 4 xenon atoms are there. So, above that axis, when we do the rotation through 90 degree, all the 4 fluorines are going to be interchanging. So, we are going to have an indistinguishable configuration. So, that is a C4 axis. Again, perpendicular C2s are not there. So, it doesn't belong to the D-type point group. Now, we have to search for no sigma H cannot be present, because only the on the top side we have oxygen, bottom side we don't have anything. So, we cannot have a sigma H. Instead, we can think of a sigma V. So, sigma V will pass through xenon, oxygen and 2 opposite fluorine atoms. And 2 more sigma V will pass through xenon, oxygen and bisecting the line joining the adjacent fluorine atom on both sides. So, yes, that is a beautiful plane. So, like that, you are going to have 4 sigma V in the molecule and C4. That is why this belongs to the point group C4V. The next one is so the next one is a CNH point group. So the example is, we can think of the hydrogen peroxide, the trans hydrogen peroxide. So you have a C2 axis, so passing through the OO bond, bisecting the OO bond, and then it is not having two more C2s. So it belongs to the C-type point group only, and along with that, it has a sigma H. So which is a sigma H present in the molecule. So you can think of a plane what is remaining perpendicular to the C2. Therefore, it belongs to the point group C2H. The next example is where trans 1,2-dichloroethene. See, when the configuration changes, this molecule belongs to C2V, whereas the trans molecule belongs to C2H. So you can think of a C2 axis. So it is bisecting the two carbon atom and remaining perpendicular to the molecular plane. That is a C2 axis. So what will happen is diagonally opposite atoms will be interchanging. The two hydrogen will be interchanging, two chlorine will be interchanging. That is a C2 axis. Then you can think of it is a planar molecule. So molecular plane is going to be the sigma H in this molecule. That is why trans 1,2-dichloroethene belongs to C2H point group. The next one is your planar boric acid that belongs to C3H. So beautifully everything is illustrated. So C3 axis passing through boron and remaining perpendicular to the plane of a molecule. It's a planar molecule. Then sigma H is the molecular plane itself. Therefore, it belongs to the point group C3H. And the C2s are not there because of the non-collinearity of the OH bond with the BO bond. We cannot have a C2 axis in this molecule. Whereas if you are having BCl3 molecule has a C3 axis and also 3 perpendicular C2. So BCl3 will belong to D-type point group, whereas the boric acid, because of the non-collinearity of the OH bond and the BO bond, it cannot have a 3 perpendicular C2. It has only sigma H. That's why it belongs to the point group only C3V. The next one is we belong to the SN point group. So the example is, so this is one molecule, tetraphenyl methane. So this belongs to, so SN. So it is an S4. Already we have seen a tetrahedral molecule has only a C3 axis, but it has an S4 axis. So this belongs to the S4 point group. So now we'll go to the DN type point group. So skewed ethane. So ethane neither having the eclipsed conformation or the staggered conformation. This is called as a skewed conformation of this ethane. So this has a C3 axis passing through the CC bond. And then it has 3 C2. And every C2 will bisect. It will pass through, it will bisect the CC bond and bisect the 2 front hydrogen and the 2 back hydrogen. So it is difficult to show the axis. You can imagine. So 3 hydrogens are facing you, 3 hydrogens are away from you. So you can think of an axis bisecting one front hydrogen, back hydrogen on both sides. And it will bisect a CC bond also. So like that, you are having 3 front and 3 back hydrogen. So you can think of a C2 axis bisecting the front and the back hydrogen on both sides and bisecting the CC bond also. So all these 3 C2s are going to be lying on the plane, which remains perpendicular to the C3 axis. That is why the Q ethane belongs to the D3 type point group. The next one is DNH. So simple ethene. This belongs to D2H point group. Now, it's a planar molecule. Now you can think of 3 C2 axes. One is the axis bisecting the CC bond and remaining perpendicular to the plane of a molecule. that only I am choosing as a principal axis. It is a convention. Normally, whenever, especially for a planar molecule, whenever we have an axis, see an axis remaining perpendicular to the plane, that should be chosen as a principal axis. And apart from that, we are having two more axes also. You can think of, see in the slide beautifully given. So yes, that is one C2. So bisecting, another one C2 also bisecting. The two adjacent hydrogen attached to the same carbon, and another one is bisecting the left hand side, the two hydrogen passing through CC bond, and is bisecting the right hand side hydrogen also. So one principal C2 axis, what is remaining perpendicular to the molecular plane, and other two C2s are also remaining perpendicular. So it belongs to the D type point group, D2, D2H or D2D. Then we have to identify whether sigma H is there or not. So you have a sigma H in this molecule. Molecular plane itself is sigma H. That's why it belongs to the point group D2H. The next one is BCl3, boron trichloride, and also phosphorus pentachloride. These two molecules belong to D3H point group. So BCl3 easily you can see there is a C3 axis passing through boron. And then there is a molecular plane what is remaining perpendicular to the C3 axis. Then apart from that, you are having three C2 axes. So what are all the three C2 axes? C2 axis will remain pass through boron and another chlorine. And like that you are having three C2s are there. And three C2s are going to remain perpendicular to the C3 axis. And the sigma H is also there. So that is why it belongs to the point group D3H. Same thing with your phosphorus pentachloride also. So even though it's a trigonal bipyramidal geometry, so it is something like this only. So you can think of a C3 axis passing through phosphorus and the two axial chlorine. So that is your C3 axis. Then you can think of three C2 axes passing through phosphorus and every equatorial chlorine. So beautifully shown in the slide. So it belongs to the point group D3, D3H or D3D. And then you can think of a trigonal plane. It is a symmetry plane in the molecule. Therefore, that becomes sigma H because it remains perpendicular to the C3. So it belongs to the point group D3H. The next one is a tetrachlororation. So it is having a square planar geometry. It belongs to D4H point group because there is a C4. Then 4 C2s already we have seen in a square planar molecule, sigma H also, therefore it belongs to D4H point group. Then if you take benzene, C6 is a principal axis, sigma H already I have told you. Then 6 C2s you are going to have. 3 C2 will pass through diagonally opposite CH and 3 C2 will pass through, will bisect the opposite CC bond. So 3 C2 bisecting the opposite CC, then 3 C2 passing through diagonally opposite CH. So totally you are having 6 C2s and then you are having a C6 axis. So it belongs to D6 type point group. And along with that, you have a sigma H also. So it belongs to the point group D6H. Then next one is DND point group. So this is a beautiful model. You have to understand this, especially the MSc students, CSR aspirants. So allene belongs to D2D point group. So beautifully, the C2 is shown. So it is not a planar molecule. So you are having two vertical hydrogen and two horizontal hydrogen. So yeah, C2 axis is a CC bond. So beautifully shown. Then two more C2s are also there. So that is also beautifully shown in this diagram. So that is one C2 and one more C2. So the characteristic feature of a C2 is it will bisect the CC bond, and along with that, it will be bisecting the front and the back hydrogen on both sides. So that is a characteristic feature of the two perpendicular C2s, and it's not having any sigma, that it's not having sigma H. Instead, it has 2 sigma D. So instead of C2, the two perpendicular C2, we are considered axis. Instead of choosing the axis, you consider those planes. Those planes will become the symmetry planes. So because of that, it belongs to the point group D2D. Then staggered ethane in the same way, we can show it belongs to D3D point group. So the CC bond is a C3 axis. Then 3 perpendicular C2s. So the characteristic feature is every C2 will bisect the CC bond and one front and the back hydrogen on both sides. So 3 C2s you are going to have. And then instead of choosing the C2 axis, you can consider the planes and then do the reflection. The planes are also beautifully shown here. So it is passing through the front and the back hydrogen. Okay. So 2 front hydrogen and 2 back hydrogen and the carbon atom, of course. So it becomes a symmetry plane. So like that, you are going to have 3 more planes. That's why it belongs to the point group D3D. So I would say this Aline and staggered ethane, beautiful presentation in this slide. With this, you'll be able to understand clearly how the molecule belongs to D2D and D3D. The next one is, it is a tetrahedron molecule. So it belongs to the point group TD. So it is going to have 24 elements of symmetry. Then it is an octahedral molecule. So close your eyes and then write the point group as OH. So it is going to be having 48 symmetry elements. Then it is an icosahedron molecule. So it's going to have 120 symmetry elements and it belongs to the point group IH. These are all the special point groups. Then next one is, see this gradation also, if you understand, then that gives a better information, better view about the group theory. So it belongs to, it's a tetrahedral molecule. So it belongs to TD point group. So it is a simple methane. Now, one hydrogen I am replacing by chlorine. So I am having methyl chloride. Now what happens? Now in the tetrahedral molecule, we are having 4 C3 axes. Whereas here only 1 C3 axis possible. So we have to follow the flow chart. Then apart from a C3 axis, we don't have any other C2 in the molecule, because for having a C2, you understand that you should have V-type geometry in the molecule, because V has a C2. So we have one V this way, the bottom, whereas up we don't have a V configuration. We have a different ball, different red ball and one blue ball. So we don't have a V conformation up, but we have a V conformation down. So only when you have V, you can think of a C2 axis. Now C2 is not there, but instead it contains 3 sigma V. So it almost resembles your ammonia molecule. Difference is the non-bonding electron present on the nitrogen is replaced by chlorine, that's all. So it belongs to the point group C3V. Now we are replacing one more blue ball by red ball. So it is your CH2Cl2 dichloromethane. Now this has a C2 axis. Just now I have shown a V-type geometry. So there is one blue V and also one red V. So the slide beautifully tells you one blue V is there and one red V is there. Whenever you have V, it has a C2 axis and it almost resembles your water molecule. So it appears, or it is similar to the joining of 2 water molecules, one water molecule up and one water molecule down. We know that water molecule belongs to C2V point group. Therefore, the point group of this molecule is also going to be C2V. The next one. Now we are replacing one red ball by one green ball. Now what is a point group? So now we don't have a C2 because one V is there, other V is not there. So no C2 axis also. But one plane we can think of. What is a plane? You can think of a plane passing through carbon, the black ball, green ball and red ball. You can think of a plane passing through these 3 and then bisecting the 2 balls, 2 blue balls. So that is going to give the indistinguishable configuration. So there is only one symmetry plane present in the molecule. So it belongs to the point group CS. Then next one is, we have replaced everything. All are different balls. So it is an asymmetric molecule. So it belongs to the point group C1. Not CI, it is only a C1 point group. So when the symmetry reduces, accordingly the point group also changes. So tetrahedral molecule has 48 elements of symmetry, whereas When the symmetry reduces, C1 point group has only one symmetry element. So as the symmetry drops down, not only the nature of the point group changes, number of symmetry elements also gets decreased. Then one more slide also we have made. So with the octahedral substituted octahedral molecule, look at it. It's a perfect octahedral molecule. So the point group is OH with 48 elements of symmetry. Now, one axial or one atom we are replacing by the yellow bond. So look at it. So now we are having a C4 axis passing through the middle one and the two axial groups. So that is a C4 axis. Then apart, this is something similar to your XeO4. So it belongs to the point group C4V. The next one, we are going to replace. So it is a trans disubstituted octahedral molecule. Now, this belongs to the point group. So it has a C4. And apart from a C4 axis, because the axially up and down are same, you are going to have 4 C2 axis also along with the C4 axis. So this belongs to the D4 type category. And apart from that, the square plane has become a sigma H. So it belongs to the point group D4H. The next one is, so we are replacing the two cis geometry. So disubstituted cis disubstituted octahedral molecule. Now it resembles 2V. So you are able to see 1V on the left hand side with the 2 black balls and right hand side with 2 yellow balls. And then top and bottom are same. So whenever you see V shape, you can think of the C2V point group because it resembles your water molecule. So it is, you can imagine like this. So if you develop this methodology, so you can imagine that this molecule is made up of, or by joining two water molecules. Water molecule has C2V. So like that, this cis disubstituted octahedral molecule resembles your joining of two water molecules. So this also belongs to the point group C2V. So like that, when this geometry varies, or when we introduce more and more dissymmetry in the molecule, automatically the number of symmetry elements present in the molecule keeps on decreasing. So if you look at your octahedral molecule, it contains 48 elements of symmetry, whereas C4V is going to have only 8 number, and D4H is going to have 16 symmetry elements, whereas C2V point group going to have only 4 symmetry elements. So when the geometry varies, accordingly symmetry elements and the point group also varies. Then almost we are coming to the last, because time allotted is only 15 minutes. I have exceeded. Anyway, I'll try to complete this. So it's an order of the group, and then you should know conjugate elements and what is meant by the class in the group. So order is very simple. So order is nothing but the total number of symmetry elements present in the group, and it is indicated as H. So you have to understand, in group theory alone, H has a different significance. Normally, in all other physical chemistry chapters, H is called as a Planck's constant, whereas here H is called as an order of the group, which indicates the total number of symmetry elements present in the point group. And then, using this table, easily you can find out what is the order of the group. So, CICS contains only 2. Then, CN contains n number of symmetry elements, because n happen to be the associated symmetry operations of a CN axis. Then, next one is CNB, CNH, DN. They are all going to contain 2n. So we'll see some example. So when I take C to V, n is equal to 2. So how many symmetry elements we are expecting to be present? 2 into 2, 4. So water molecule has 4 elements of symmetry. Similarly, C2H also will contain 4 symmetry elements. Then when we come to DNH and DNT, they will have 4n as the order of the group. For example, D2H point group, ethylene molecule, when we take, it belongs to D2H. So it contains 8 symmetry elements, because DN point groups will have CN axis. So CN itself will have n number of associated symmetry operations. Apart from that, it is going to contain n number of perpendicular C2 also. That is the reason why. And apart from that, it's going to contain n number of sigma V also. and then sigma h is there. So Cn sigma will give you Sn operations also. That's why totally it accounts for the order of the group as 4n. And apart from that, tetrahedron will have 24 elements of symmetry. If you refer to any group theory book, you can easily now understand what are all the 24 elements of symmetry. See, you have to look into all these symmetry elements. See, that alone will give you better visualization of geometrical entities, symmetry elements, and how to identify them in the molecule. So that whatever molecules given in the examination, you will be able to work out and then easily find out the point group. Then octahedron molecule has 48 elements of symmetry. Then icosahedron is going to contain 120. Icosahedron you can leave it because 120 elements it is difficult to solve. Then if you look at the conjugate elements, you have to understand this point alone essentially, especially for the MSc students. So what is meant by conjugate element is, see, we may have A and B present in a group. It's a mathematical definition only. Now, when we do similarity transformation on A with some other element X present in the group, and if it leads to another element B of the group, then we say that A and B are conjugate elements. See, similarity transformation and all, only the name looks complicated. It's very simple. What we do is, we are taking the element A. We are choosing some other element X. So what we do is, A we are multiplying on the left hand side by X inverse and the right hand side by X. So what is X inverse? X inverse is the inverse of the element X. What is the definition for inverses? So it is also a symmetry element, which when multiplied by the element will give you the identity element. So I can say X inverse into X or X into X inverse should give me E. So if I do X on a molecule first and then X inverse on another molecule followed by X, then if I get E, then I say that X inverse X is nothing but the inverse of the element X. Now, what is similarity transformation? We are taking an element A, we are multiplying right hand side by the element X and left hand side by its inverse. And then if that trinary product is going to give me another symmetry element B, which also belongs to the point group, then we say that A and B are similar elements. Or we have a special name as conjugate elements. And these conjugate elements, we can club into the same class. See, all the second BSc students we are putting in the same class. All the first BSc students we put in the same class. Same thing here also we are doing in group theory. A and B, they are different elements, but they are all the similar category. How do we identify that they belong to the similar category? By doing similarity transformation. So we multiply by some other element X on the left hand side and X inverse on the right hand side, so that if it gives B, we say that it is a conjugate symmetry elements, and the conjugate elements belong to the same class. But you don't have to do all these things, and you have to identify the elements belonging to the same class. So we are giving a table. So using the table, very easily you can identify the number of classes present in the molecule. And the total number of classes present in the group is indicated by K. H indicates order and K indicates total number of classes. So if you have these 4 rules, easily you can identify the classes present in the group. That is E, sigma H and I. They form separate class because they commute with every other symmetry element. Then, because commutation and all of you may be knowing, you would have studied in your mathematics. Then, the principal axis Cn and its inverse. Similarly, the Sn and Sn inverse, they belong to the same class if a molecule contains sigma V. Or in the absence of sigma V, at least a perpendicular C2 to Cn is present in the molecule, then we say that Cn and Cn inverse, they are conjugate elements and they belong to the same class. Same thing applicable for your Sn and Sn inverse. Then, next rule is, say, apart from principal axis, we can have some other axis also. Cn and Cn prime. So many C2s we have in the molecule. So we have to check whether Cm, Cm prime, they belong to the same class or not. For that, what we have to identify is if atoms or groups present on Cn can be moved to Cn prime by some symmetry operation of a point group, then we say that Cm and Cm prime, they belong to the same class because they are the conjugate symmetry elements. Same thing with your sigma V and sigma V prime, because so many symmetry planes you can think of. So sigma V and sigma V prime, they belong to the same class. If the atoms are groups on sigma V, we can shift it to sigma V prime and vice versa by means of some other symmetry operation or symmetry element present in the point group. So if we can do it, then sigma V and sigma V prime, they are conjugate symmetry elements and they can be clubbed into the same class. See, for example, when you take C2V, it contains 4 symmetry elements. What are all the 4 symmetry elements? A, E, then we have seen C2, and 2 sigma V also we have seen indicated as sigma XY and sigma. It's not sigma XY, it is sigma XZ and sigma YZ. Because normally the principal axis we take it along the Z axis only. C2Z, sigma XZ and sigma YZ. Then all these 4 symmetry operations or symmetry elements, they belong to 4 different classes because none of them are conjugate symmetry elements because only C2 is there. We don't, the inverse of C2 is C2 itself. Then both the sigma V are very different. One is a molecular plane containing oxygen and 2 hydrogen, and other plane is passing through only oxygen. We cannot shift atoms of one plane to other one by any other symmetry operation. That is why all of them are belonging to separate classes. So 4 classes are there in a C2V. Whereas when you take C3V, there are actually 6 symmetry elements. Order of the group is 6. E, C31, C32. Then 3 sigma V are also there. But C31 and C32 are element and the inverse. C32 is the inverse of C3. So they belong to the same class because you are able to see the presence of sigma V. I have given the condition in the same slide you are having. Because of the presence of sigma V, C31 and C32, they belong to the same class. So they become the conjugate symmetry elements, and because of that, they are clubbed into the same class. We call it as a C3 class. E class, C3 class. Then 3 sigma V also belong to the same class because we can shift the atom present on one sigma V to other sigma V by doing C3 on it. Simply by doing C3 on one sigma V, we can shift the atoms on one sigma V to the other one and vice versa. Therefore, the 3 sigma V, they belong to, or they are remaining as conjugate elements because we are able to do similarity transformation with the C3 and the C3 inverse on sigma V, and we could transfer to another sigma V. That is why they belong to the same class. So even though it contains 6 symmetry elements, they are clubbed into 3 classes. Whereas if you look at the C3 point group, C3 point group will have E and C31 and C32. Now, order is 3. Okay, order is only 3. Whereas, due to the absence of sigma V, C31 and C32, they belong to different classes. So
Madam,
a C3 point group.
Madam, excuse me, ma'am.
I'm finishing, sir. This is my last slide.
Ma'am, audio varla, ma'am.
Oh, nothing is there. Same.
Yes, now it is okay, ma'am.
Okay. So C3 point group contains 3 symmetry elements. Order of the group is 3. And then number of classes also 3 for the C3 point group because E belongs to separate class, C31 belongs to separate class, and C32 also belongs to separate class. So like this, by identifying the conjugate elements, by the given rules above, you can find out the number of classes also present in each and every point group. I think with this, the preliminary discussion about the group theory gets over. So I have to thank the organizers, especially principal, HOD madam, faculty members, and Muthukumaran sir for giving the beautiful opportunity to share little group theory with the young minds. So I'm sure for the CSR aspirants, this is an initiative session. So with this presentation or with the slides, if you do little more studies, extended studies, you can definitely score 9 to 11 or 12 marks. I mean, definitely in your group theory, because every year minimum 9 marks appearing in the CSR paper, 9 to 11 or 12 marks, very sure with this group theory. So wishing you all the best. Thank you again for the beautiful opportunity. Thank you, sir.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Happy to answer if they have any doubts. I'm sure it's the last session. After a strenuous day. Anyway, if you have anything, I'm happy to answer.
Ma'am, good evening.
Yes, good evening, sir.
This is Dr. Jaishankar from ISCB Kolkata.
Yes, sir.
I am
Good evening,
alumni.
sir.
Good evening, ma'am. I am an alumni of Chemistry Department of Presidency College in
Okay, sir.
1987-89 batch, madam. First batch of after getting the
Nice, sir. Nice,
autonomous.
sir.
You
Yes,
reminded
sir.
me exactly like Dr. Kannappan sir.
Thank you, sir.
Exactly like that. But I'm sorry, the same way I also did not understand much. Superb class. Thank you very much, ma'am.
Thank you, sir.
Really,
Thank
it
you.
is very informative. And in fact, now, see, being in the research line, my group theory and, the symmetry is restricted to only the tetrahedral because I'm
I know,
working on the asymmetric.
I know.
But now you have actually introduced all of us to kind of different kind of world, encompassing everything. It's a fantastic, presentation, ma'am, lecture.
Thank you, sir.
Thank you very
So
much.
that's what
ma'am.
I told the organizers, sir. So much research areas.
Yes.
Just finally, I want they would have expected the audience to relax. That's why. Finally, they have given a very light session of this classifying the molecule into point groups. Anyway,
Fantastic,
that's good.
Fantastic. Thank you, ma'am. Thank you.
Thank you, sir. Thank you, sir.
Thank you, ma'am, for the fabulous presentation. Your
you.
dynamic style, lively and clear presentation helped us to receive the information clearly. Thank you so much for sharing your valuable knowledge and for the excellent presentation. Thank you, ma'am.
Thank you. And I want to thank my student, Dr. Pocherian, who is going to become the doctorate shortly. See, but for him, the slides would not have come so well like this. So he is responsible for making the beautiful slides. So I thank him so much for making the presentation also during the lecture. Thank you.
Thank you.
Thank you, Mr. Porcherian. Thank you, sir.
Sir, thank you so much, sir.
Thank you, ma'am. Thank you, ma'am.
Thank you, madam.
Ma'am,
Thank you, sir.
vote of thanks by PJ, sir.
May I now invite Dr. V. Jaishankar, Associate Professor, Department of Chemistry, Presidency College, to propose the vote of thanks.
Audible now?
Yes.
Yes, sir.
Respected Principal, Dr. O.R. Devanathan, Head of the Department of Chemistry, Dr. Indira Gandhi, resource persons, my dear colleagues, and the participants of webinar, a warm evening to one and all. I deem it a privilege to have been asked to extend a vote of thanks on this occasion. First, I extend my wholehearted thanks to our principal for his unstinted support and guidance for conducting this webinar. I also thank our head of the department, convener of this webinar, who has delivered the thematic inaugural address yesterday for coordinating this webinar successfully. The very presence of our regional joint director, Dr. Ravanan, in the inaugural session has motivated us. Thank you, sir, for your deep sense of appreciation. At this juncture, I would like to mention quote from our Sangam literature, Tirukural, Yapporul yar yar vai ketpinum, apporul meipol kanbadarivu. To discern the truth in everything, by whomsoever spoken is wisdom. So this is a chapter, Ariyudamai, which is the possession of knowledge. The past 2 days of webinar, we gained the knowledge from rich resource persons. There are 8 resource persons from various prestigious institutions, shared the rich experience and expertise, and pays to promote quest for teaching and research in the field of chemistry. So I'd like to mention the resource persons, Professor Dr. Parameswaran Jaishankar, Chief Scientific Scientist, Head IICT Kolkata for NMR Techniques, Professor A.K. Ghosh from BAR Mumbai for Membrane for Chemist, and Professor Dr. S. Prabhakar, Desalination Division, BAR Mumbai, Membranes for Environmental Safety, and Professor Dr. M. Jagan Mogan, IIT Madras, for lecture on metal catalyzed CH alkylation reactions, and Professor T. Anil Mithal Ghosh from Shivaji University, Maharashtra, for lecture on sustained technology from Green Chemist. Professor Dr. Murugan Pattaswamy, HRM Analytics from University of Hyderabad for online teaching methods. Professor Dr. R. Natarajan, Principal Scientist, CSR IICT Kolkata, on supramolecular self-assembly of metal volcanic cages. And finally, we have a emeritus Professor Dr. Swarnal Ashmi from Guru Nanak College as a delivered lecture on group theory and point group classification. On behalf of Department of Chemistry, I thank each and every resource person for their outstanding contribution in this webinar. Well, an event like this cannot happen overnight. The wheels start rolling weeks ago. It requires planning and a bird eye for details. We have been fortunate enough to be backed by our faculty, Dr. Muthukumaran, for success of this webinar. Thank you, sir, for a result-oriented effort for success of this webinar.
Thank you, sir. Thank you, sir.
I'd like to take this opportunity to place on record my thanks to Dr. W. Shantni for this 2 days webinar with a unique style. Thank you, madam. I also extend my thanks to Dr. R. Sundaram for technical assistant during these days. I also extend my special thanks to all the faculty members of our department for the cooperation in this webinar. I thank all the head of the departments of our college and staff members of Presidency College for their support and encouragement. So I extend my thanks to Mr. Akash Karthikeyan for monitoring the YouTube link during this webinar. He's a son of Dr. Karthikeyan from Dr. Ambedkar Government Arts College. So in this webinar, nearly 400 participants from various institutions across our country have joined in this webinar through virtual platform. So virtual means the main nigger Madai. There's a reality like seminar. So this reflects the success of this webinar. I also thank all the participants who has joined in this webinar and they benefited by the seminar. The best and beautiful thing in the world cannot be seen or even touched. They must be felt by heart to heart. Thank you is one such prayer among them. I thank every one of you for cooperating, for conducting the successful webinar in our college, the Department of Chemistry. Thank you very much.
Thank you, sir.
Thank you, sir. Thank you very much, sir.
Thank you.
So I'm very happy to thank you all the resource persons and the faculty members of Department of Chemistry for their sincere cooperation to make this event successful. Thank you all. Thank you, sir. Thank you, madam.
Thank you. Thank you, sir. Thank you.
Thank you, sir. Thank you very much.
Thank you, sir.
Thank
Bye.
you. Thank
Bye.
you.
Nice, sir. Nice.
Yes, sir. My special thanks to our head of the Department of Chemistry, Dr. N. Indira Gandhi, ma'am, ma'am only has given liberty to do this type of things. So I have to be very much thankful to you, ma'am. Thank you very much, ma'am.
Thank you, ma'am. Thank you very much from my side also. Thank you.
Thank you so much.
Thank you, sir.
Madam, thank you so much.
Thank you. Thank you, ma'am. Shall I end the meeting, ma'am? Actually, ma'am. Sir,